Hello folks, this is VK3 Alpha Mike Lima with the regular Saturday night live stream, and we'll go to the live camera in just a moment. Just to prove that we're on live, I'll put my hand up in front of the test card. There we go. And I'm hoping to do some Zoom chat at about 11 PM Melbourne time tonight. Just repeating, just in case that was missed, this is VK3 Alpha Mike Lima with the regular Saturday night live stream. Wishing you all the best from Burwood East, a suburb 20 kilometres to the east of Melbourne City in Australia. Okay, we'll go over to the live camera at this point. With a quick change. Hello folks. Tonight's live stream is a very full program. To prevent it going over to over the 11 o'clock deadline, I'll start a couple of minutes early, and I'll probably finish a couple of minutes late. Quite a few of the clips tonight, courtesy of other people, Bell Telephone Labs for the first two of the helium neon laser and laser safety in the 1960s. Later you'll see the presentation that I put together with Clint Turner, KA7OEI, and Mike Groth in Hobart, VK7MJ, in 2008 for the Photonics West exhibition, an optics exhibition in San Jose, Silicon Valley in California, which we delivered in January 2008, and that gives our background in ham radio optical communication up to that time. Following that, a shot taken by Dave Stuart VK3ASE of our successful Trans-Strait Tasmania-to-Victoria optical communication transmission in January 2021, about 18 months ago now. And finally, Barry Chambers, Dr. Barry Chambers, giving a talk in Britain on his own efforts in optical DX work. He's G8AGN, and I think he very clearly summarises the whole of the present state of the amateur art. It being 9:30, I'll go on the air. Hello. Hello, he said, with his scanner having wandered off the frequency. There it is, I'll lock it on again. VK3 Alpha Mike Lima opening the test transmission for the 8th of October 2022. We are live streaming this on YouTube. If you want to look in on the visuals that go with this, and there are some very pertinent visuals this week, please Google VK3AML 8 October 2022. That's VK3AML 8th October 2022. Now tonight's subject will be optical communication, modulated light communication, which there isn't a great deal of documentation for on YouTube. I hope to change that a little tonight. First of all, two clips from Bell Telephone Labs detailing their development of the helium neon laser in 1962. Consequently, also following that, a film made on laser safety in 1969. After that, a scientific paper that Clint Turner, KA7OEI, Mike Groth, 7MJ, and I put together for the Photonics West Optics Conference in San Jose, Silicon Valley, where we went in 2008 to present it. You'll actually see that lecture tonight. Then a little bit of our Deal Island to Victoria optical communication test, full duplex two-way speech sent on a light beam from Victoria to Tasmania, from Blackwarry in Victoria, where Ralph Edgar VK3WRE and Chris Morley VK3CJK were stationed. We were on Deal Island in Tasmanian territory. Myself, Dave Stuart VK3ASE, who shot the video, Stephen Langley, VK3SL, and Henry Langley, VK3FACT, all talking over the light beam to Victoria. And finally, and most notably, I'm taking a bit of a risk. I have written to Barry Chambers, Dr. Barry Chambers, G8AGN, to try and get permission for live streaming his lecture on optical communication for amateurs, amateur optical communication, that he gave to the Cardiff University Amateur Radio Club in 2019. So without any further ado, this is a fairly long night's program, so I hope we don't overrun too far. We're likely to go to 11:15 with this before we go live for callbacks. So now over to the film. Please, if you want to see the visuals that go with this audio, if you're listening on 147.475, please Google VK3AML 8 October 2022. Over to the films.
These are the patterns of invisible waves we use today for communications. Radio waves, television waves, microwaves. In the same family, of vast potential for tomorrow, are visible waves, the waves which man calls light. In other centuries, they would have called it magic. Voice by waves, pictures by waves, machines that talk to other machines by waves. There is still a quality of magic in it, this manipulation of invisible waves by which man relays messages across vast distances, by which he controls and guides waves, amplifies them to extend the limits of communications. For almost a century, scientists have been challenged by the knowledge that light waves are like radio waves, but are visible. But science knew no way of generating and controlling light waves as it controls the radio waves with which we are more familiar. Today, research scientists in many areas are experimenting with light. In the communications industry, there is special interest in a special kind of light wave, known as coherent light. Coherent light, the scientists know, can be precisely directed, amplified, and controlled. And theoretically, a system using coherent light could provide a communications highway of staggering capacity, a potential capacity of more than 1 million telephone conversations or 1,000 television channels. Man has long since generated light for vision, but this ordinary light by which we see is wayward, undisciplined, a jumble of waves of different sizes and colors radiating outwards in wild disorder. How can light, in nature undisciplined, be harnessed for communications, which needs a constant coherent flow of light in only one direction? At Bell Telephone Laboratories, day by day, scientists have under development a new device which could revolutionize man's use of light. It is called a laser, or sometimes an optical maser. The light it generates is a kind of light never before known on Earth. It flows in a narrow beam, as nearly parallel as nature allows, a constant stream of precisely controlled light, coherent light. There are many types of lasers. A laser may be a large glass tube specially formed to hold helium, neon, or other gases. It may be a liquid, glass, or plastic, or the heart of the laser may be a tiny crystal made to precise specifications. Inside this laser, equipped with special mirrors, atoms are excited with an external light source. When they are weakly excited, the atoms begin to give off light independently of one another. However, when they are strongly excited, conditions are created which force the atoms to release light all to the same beam. The beam gets brighter as it moves within the laser. In a fraction of a second, it builds up millions of times and bursts through one of the mirrors. A beam of light more intense and more precisely directed than has ever been produced in man's history. In 1958, ideas basic to the laser were presented in a paper from Bell Laboratories by Drs. Shallow and Towns. In 1960, at various research centers, the first lasers were actually built. They were pulse lasers and could emit only short but concentrated bursts of light energy. A pulse of energy that could be made to pierce a hole in a steel blade. But the need of communications normally is not for short bursts of energy. So, work at Bell Laboratories went forward in the search for a laser that could send out a continuous beam of coherent light. The scientists who built this laser, who coaxed it to give forth light, gave it a name. They called it Eve. February 1961. The first continuous coherent light on Earth. Today, man can produce in many variations a kind of light totally new to his experience. A light which begins in waves so nearly parallel that its rays hardly diverge at all, no matter how great the distance. A light more purely one color than any light we have known before. A light 10 million times brighter than the light on the surface of the sun. The scientist is an explorer, moving day by day from the known to the unknown. And, like the explorer, he may have hopes which he prefers to leave unspoken. Yet in this light, which moves in patterns whose implications are not yet grasped, even cautious science sees a giant step forward in man's conquest of light and of his universe. For in the laser's light are endless possibilities. Another means of illuminating the age-old secrets of the human cell. Another pathway to research in the spinning worlds of atomic structure. An ingenious microscopic welding torch. A delicate tool for surgery. Tomorrow, light may be a major medium over which men communicate, a possible answer to the ever-growing need for channels of communication. Science itself cannot know the total promise, for it stands now only at the threshold of its exploration. Yet, this narrow pathway of light leads surely to tomorrow. Because it spreads so little, it may help man to map the moon. Projected toward the shadowed valleys, 250,000 miles away, a laser beam can be focused on a tiny area only a few hundred yards wide. A bridge of light, a bridge across which man may communicate on Earth and in the endless reaches of outer space. The laser, a dramatic achievement in the conquest of light.
This documentary is on laser safety, made in 1969. If this doesn't freak you out, be aware that our modern methods of communication are much safer than what the lasers they show here. VK3 Alpha Mike
The
Lima.
laser, a useful tool in industry, science, and medicine. But the laser is a double-edged sword. On one side, a beneficial tool. On the other, a dangerous instrument that can be harmful to those who use it. The beam of a ruby laser can burn through steel instantaneously. Some laser beams cannot be seen. The CO2 laser beam is not visible at any time. Only its effects can be seen. Normal clothing offers no protection from the laser beam. Almost any fabric will catch fire. Not only is the direct beam dangerous, but reflections also may be hazardous. An ordinary diamond ring will scatter reflections in many directions. This invisible hazard can cause much damage to the eye. Two kinds of reflected beams may be present in laser operation: specular and diffused. Specular beams are reflections from a lens. They can be thrown in any direction from the lens surface. Anyone in the area may come in contact with the reflections. Specular reflections, in turn, may reflect off of any number of objects in the area. Even turning the head may not be a protection. Diffused beams are reflections from the laser target area. Diffused reflections tend to spread the beam over a wider angle, often diminishing the intensity. In some instances, contrary to the obvious, the farther away one stands from the target, the greater will be the damage to the eye. Eye damage can be caused by very low energy levels. It takes only a small amount of the output of a 1-joule ruby laser to cause injury to the eye. Laser radiation falls within a very narrow portion of the electromagnetic spectrum. Various wavelengths cause damage to different parts of the eye. In the visible region, most of the radiation is focused by the lens onto the retina, the usual place of injury. The focusing effect increases the intensity of the radiation on the retina. For lasers operating in the infrared near the visible, the effects can be similar to those of the visible. Far infrared radiation, however, is absorbed by the cornea and conjunctiva. If the wavelength is shorter than that of the visible, it is ultraviolet and is absorbed by the cornea and the conjunctiva. At ultraviolet wavelengths closer to the visible region, because of the focusing characteristics of the eye, both the cornea and the lens may be injured. At ultraviolet wavelengths approaching the visible range, the radiation at the retina may be more intense than in the intervening tissues. Safety glasses should be worn at all times during laser operations. Since protective eyewear is available for different kinds of lasers, one must be certain that the glasses which are to be worn provide protection at the laser wavelength which is to be used. Wavelength must be noted on the glasses. For long-range laser uses, such as in satellite tracking, there are several ways of figuring safe levels of exposure. One of these, the nomogram, figures in the loss factor due to the beam passing through the atmosphere and through the tissues of the eye. The aperture of the average pupil. The laser output energy in joules. The concentration of energy on the retina. And the beam divergence, thereby calculating a safe distance. As part of NASA's Earth physics program, several satellites are being tracked by the laser ranging systems located at Goddard Space Flight Center and other facilities in the United States. Anyone in an aircraft intercepting this beam at close range could conceivably receive serious eye damage. To prevent this from happening, the lasers operate in conjunction with radar and visual observers.
This is radar. We have spotted a bird. Kill your laser.
Roger.
In order to provide a safeguard for low-flying aircraft, the laser operator works with a visual observer during tracking operations.
Aircraft coming. Kill the laser.
Roger.
The high voltages required for the operation of lasers present another safety hazard, the high voltage power supply. It is designed to be safe. When the power supply door is open, the safety interlock on the access door automatically shuts off the power supply. However, there still may be high voltage remaining, high voltage which can kill instantly. Because of this danger, maintenance should be performed by two individuals, since several manual operations may have to be handled simultaneously. To make certain it is safe to work inside, all high voltage points must be grounded and remain grounded. This will dissipate any stored charge remaining in the capacitor. This demonstration shows what may happen if it remains charged. Many of the materials normally used around laser operations are flammable, and specular reflections could set them afire.
Bang!
Cryogenic materials can be dangerous. This bottle of dry nitrogen should be strapped securely to a solid object. Should the bottle fall over and the regulator break off, the gases will propel the tank with extremely destructive force. Laser operation may result in the production of dangerous gases. In this demonstration, a synthetic object is struck with a laser beam, thereby releasing toxic gases. The laser laboratory should be ducted for the safe removal and disposal of various toxic gases. Any room in which a laser is operated should have certain basic safety features. The laser and its power supply should be positioned against a blank wall so as not to block any escape route for the operator. Indicator lights on power supplies should be visible to the operator when wearing laser glasses. There should be an adequate beam stop. The laser system should be isolated from any other activity in the room with a safe partition, such as a blackout curtain or folding screen. All windows and door windows should have blackout curtains or some other absorbent material. Safety interlocks should be provided for all doors, the primary entrance and the secondary entrance, such as the isolating screen. The interlocks are connected to the power supply. When the power supply is turned on, the interlock switches lock the doors so that no one can enter during laser operation except in emergencies. The lock should not prevent quick exit from the room. Exhaust ducting should be installed over the target area to carry off toxic gases. The laser should be positioned well below normal eye level. Laser warning signs should be displayed prominently at all entry doors and near all laser operations. The laser can be a dangerous instrument. It can be harmful to those who use it, but to those who use it safely, it is a tool which can benefit mankind.
And this is VK3 Alpha Mike Lima with the regular Saturday night test. I'll just halt the image there for a moment to say that this next lecture was given in Silicon Valley, authored by Mike Groth VK7MJ, Clint Turner KA7OEI, and myself. I delivered the lecture in January 2008 in Silicon Valley at the Photonics West conference at the Marriott in San Jose. So this is the lecture from, what is it now, 14 years ago, that lists the amateur activities in Australia up to that time. VK3AML. This is a presentation by amateur radio operators, radio hams. Our experiments are always self-funded and tightly budgeted. Our interest lies in exploring the range limits of terrestrial optical communication. To us, commercial viability, high reliability and broad bandwidth are secondary considerations. We do our experimenting inexpensively and hopefully have a little fun along the way. Our experiments began in the southeast of Australia. On February 19th, 2005, we set a world record for a two-way speech-modulated optical contact across the island of Tasmania.
The time has come, the war is said to speak of many things, of ships and shoes and sealing wax, of cabbages and kings. I can hear you, I can hear you!
More recently, an associated group in Utah refined these techniques and confirmed their validity by setting a further world record of 278 kilometres between mountaintops in Utah. They did not use laser light, high power or expensive optics to do this, but they did span 2/3 of the state of Utah. Perhaps the first serious amateur radio contribution to optical communications was made by a team from the Electro-Optical Systems Amateur Radio Club of Pasadena. In 1963, just months after Bell Labs demonstrated the first visual output helium neon laser, the Electro-Optic Systems team transmitted a speech-modulated beam right across the Mojave Desert. The log tape of that transmission tells the story.
May 4th, 1963, the time approximately 21:32. POP operating portable from Grassy Hollow in the San Gabriel Mountains, running a test of a laser communication system over a distance of approximately 118 miles, with a radiated output power of 1/8 of a milliwatt at 125 microwatts. The transmitter uses a helium neon gas laser with confocal mirrors. The output is collimated using a 10-wire telescope. The laser is pumped and modulated using a Viking 2 at 28.60 megacycles. The receiver is located at about 12 miles from Ballarat on a ridge in the Panamint Mountains. The receiver uses a 12.5-inch diameter telescope as an antenna. The received signals are modulated using an S20 photomultiplier tube and further amplified and fed into a loudspeaker in a recorder.
This may be the oldest sound recording to indicate the severity of fast fade or scintillation on a coherent beam sent through the atmosphere. If we lived in a vacuum, laser light would be ideal for communications, but in passing through moving air cells of differing temperature and density, coherent wave fronts randomly cancel and add. Scintillation, fast fade, is the major problem. Only optical fibre transmission can completely eliminate it. The 1963 electro-optic systems test used a laser beam expander. By aperture averaging across the beam profile and straddling adjacent air turbulence cells, this expander reduced scintillation sufficiently to make their speech modulation intelligible. Unfortunately, large laser beam expanders have to be made with diffraction-limited precision optics, and they're very expensive. Here's Clint Turner's video comparing a laser beam with a light-emitting diode beam on a 24-kilometre atmospheric path. The camera is focused on the receiver's Cassegrain telescope mirror, 20 centimetres in diameter. With the laser, the speckle pattern is a chaos of deep rapid scintillation extending up into the kilohertz region. This laser beam has a minimal capacity to convey recoverable modulation. Now the beam from a light-emitting diode, expanded to 20 centimetre diameter by a collimating lens. The scintillation is slower and shallower, around 7 dB fades at 10 Hz. The beam's capacity to convey recoverable modulation is much greater than the laser, even if the beam flux is lower. Could it be that coherence is undesirable on atmospheric optical links? The physicist Albert Michelson indicated one cause of atmospheric scintillation way back in 1890. Light from a distant source, for example a star with an angular size less than some critical value, will exhibit local coherence, resulting in scintillation via interference. However, if we increase the space between the observing points, like this, to make the viewing aperture larger, the coherence will disappear and consequently atmospheric scintillation will fall. Large apertures mitigate scintillation. For a given aperture, shorter wavelengths also reduce local coherence, suggesting that visual wavelengths have at least one advantage over infrared for communications. Scintillation can also be reduced by using a thin diffusing filter to scramble a laser's phase coherence, reducing wavefront cancellations and signal dropouts. Korotkova, Andrews and Phillips recently indicated that partially coherent or even non-coherent beams would outperform lasers on atmospheric scintillation. The key to our success on long ranges lies in our elimination of beam coherence. John Gower's 1984 book, Optical Communication Systems, provides a first approximation formula for maximising the received optical signal. Received signal power ρ is proportional to the source radiance multiplied by the area of the transmitting lens multiplied by the area of the receiving lens. Our collaborator Mike Groth then adds a geometric correction factor G for the transmitting lens, which we'll explain shortly. This is all divided by the square of the distance between the stations, the inverse square law. Big lenses and intense light sources are essential. The geometric correction factor arises because as the transmitting collimator focal length is shortened, particularly below an F/D ratio of 1, the beam divergence increases at a greater rate than the total beam power. The geometric loss of a mirror is less than that of a lens of equivalent F/D ratio, as a parabolic mirror can surround an isotropic source, intercepting more of its flux than the flat plane of a thin lens. Intense, non-coherent sources for optical communication are improving rapidly. Standard light-emitting diodes have limited output as they don't provide sufficient heat sinking, and their epoxy encapsulant can't withstand temperatures above 120 degrees Celsius. The new Philips Lumiled's Luxion rearranges the whole light-emitting diode system. The emitting chip is mounted on a thick metal heatsink slug, and it's surrounded by high-temperature silicone encapsulant. The red Luxion's chip is shaped like a truncated, inverted pyramid, its angled walls reflecting light forward by total internal reflection. Its efficiency and power handling capacity are both greater than standard light-emitting diodes by several orders of magnitude. They're available on a small star of metal-backed circuit board for easy attachment to a heatsink, the so-called Luxion star. The red Luxion is reputed to have a modulation bandwidth in the order of 10 MHz. The red Luxion 3 can be driven to unprecedented current densities, 1.5 amp continuous at 3 volt, into a chip less than 2 mm square, with a light conversion efficiency above 30%. A laser with hundreds of milliwatts of visual output would be prohibitively expensive and hazardous to use. A Luxion's output becomes eye-safe after beam expansion via a Fresnel lens, as this greatly reduces the beam flux density. A collimator of very large aperture need not be expensive. Acrylic Fresnel lenses are reproduced by moulding like vinyl LP records, and they're available in apertures up to about 1 square metre. They're much lighter, cheaper and more robust than glass collimators of similar aperture. And modern Fresnels avoid spherical aberration, an effect present in all spherical surface glass lenses. This is caused by rays from the outer parts of the lens having a shorter focal length than rays concentrated near the lens centre. The Fresnel is a near-ideal collimator for optical communications, but moulding inaccuracies restrict them to use with non-coherent sources, as they're not diffraction limited. They're offered with groove pitches ranging from 0.125 to 1 mm, the finer pitch producing more image definition, but greater lens transmission losses. So, how fine can the image be with Fresnels currently available? This is the star Vega, imaged against a 1 mm scale by 4 modern Fresnel lenses between 25 and 40 cm square aperture. The Fresnel focal length is shortest at the top left, longest at the lower right. The image spot diameter increases with the focal length, ranging from 0.1 mm for the shortest lens to 0.45 mm for the longest. These collimators are all adequate for our purposes, with blur circles much smaller than the source chip of Luxion light-emitting diodes and smaller than the sensitive area of most photodiodes. So how do we optically couple the Luxion to the Fresnel collimator? The Luxion is supposed to have a radiation pattern following the cosine of the radiation angle, a Lambertian pattern. In practice, the red Luxion chip's truncated pyramid more typically radiates in this way, more broadly than the Lambertian model. Rotating this radiation pattern 90 degrees and superimposing the ray diagram of a Fresnel lens with an F/D ratio of 1, we see that the Luxion couples fairly well into its collimator. But the Fresnel lens only intercepts the shaded part of the Luxion's radiation pattern, about 35% of the total flux. This loss can be offset optically, as we shall see. A standard Fresnel collimator produces a beam divergence angle θ dependent on the diameter of the light source and the focal length of the collimator. When a source is too small to fill the Fresnel's blur circle, a plano-convex secondary lens of high diopter allows adjustment of the virtual source size to maximise the far-field intensity of the beam. With a Luxion large enough to already fill the blur circle, the secondary lens can make greater usage of peripheral emission from the light-emitting diode. We've found that by adjusting the relative focal lengths A and B, we can optimise the far-field beam intensity, or at least increase the beam divergence angle without losing beam intensity. The secondary lens can be very simply mounted above the Luxion with 2 bolts through the heatsink, providing a height adjustment. Our standard rigid optical housing, shaped like a truncated pyramid, places the transmitter and receiver Fresnels side by side, providing full duplex operation, continuous transmission and simultaneous reception. Plywood or fiberglass construction retains heat after sunset via thermal insulation, avoiding dewing. A photographic tripod and a rifle sight are sufficient to align the unit with the distant station. The optical housing need not be rigid. A very light transceiver, conveniently folding flat for transport, could be constructed by hinging the Fresnels to their central baffle and by using a cloth bellows over the receiver optics. Our transceivers produce a beam of around 4 to 10 milliradians divergence. VK3QM's unit throws a spot on a distant tree, a spot about a quarter the width of the full moon. And looking back into the beam of even a small Luxion-Fresnel combination, the light is clearly visible to immense distances, more than 60 kilometres in this case. Silicon PIN diodes are small, very cheap, this one retails for less than $2 American, and extremely sensitive. These simple devices have a fairly high junction capacitance, which can limit their response speed unless they work into a suitable low-impedance, low-noise preamplifier. The standard arrangement is to back-bias the photodiode and to have it working into a trans-impedance amplifier. That is, an amplifier presenting the diode with a very high DC resistance, but, by the use of a feedback resistor, a low AC input impedance. This circuit is a photocurrent to voltage converter. During the day, ambient light can cause a photodiode DC offset, which can bias the amplifier to cutoff. This DC must be blocked by using an extra resistor and capacitor, which unfortunately lowers the signal-to-noise ratio. Now, this circuit is great when a megahertz or more of bandwidth is needed, but when you're breaking records, when you're trying to maximise the sensitivity for the baseband audio that most radio hams require, that's around 3 to 10 kilohertz of bandwidth, a different approach is necessary. With this in mind, John Urek of station K3PGP devised this deceptively simple circuit. With ideal components, the photodiode's output would charge the open circuit of the junction FET's gate, and the amplifier simply would not function. But if we draw in the leakage resistances of real components, the circuit is actually rather complex. Voltage from the photodiode flows through the leakage resistance of the FET's gate, which is in the order of hundreds of megohms. The source bias voltage on the FET flows back through the FET gate leakage resistance to appear across the photodiode leakage resistance, placing some back bias on the diode. The photodiode capacitance and the gate shunt capacitance appear across the photodiode output, limiting this circuit's high frequency response. With a BPW34 photodiode, for example, this results in a 6 dB per octave high frequency roll-off above 200 Hz. There are ways to compensate for that, exemplified by some rather cunning improvements devised by Clint Turner of station KA7OEI. John Ureck's basic concept of feeding the photodiode into the open-circuited gate of the FET is retained. But Turner adds extra backbias to the photodiode through this voltage divider, reducing the detector's shunt capacitance and increasing its quantum efficiency. A constant current source transistor applies fairly high standing current to the FET, but simultaneously presents the FET drain with a high AC impedance. The high standing current maximises the FET's transconductance and thereby increases the circuit's signal-to-noise ratio. The second half of the cascode amplifier in this arrangement is a grounded base transistor stage, resisting voltage changes on the FET's drain and minimising the effect of the millicapacitance between the FET drain and the photodiode. This also adds a little bit of gain to the system. Finally, a low-noise 6 dB per octave high-frequency boosting circuit compensates for the shunt capacitance across the photodiode, extending the bandwidth to 10 kHz or more. This circuit has been measured to have 12 to 20 dB greater signal-to-noise ratio than the best transconductance circuit that we've been able to construct. Construction of this circuit is quite straightforward, the only constructional quirk being in the vicinity of the input. Where the photodiode connects with the gate of the FET, the extremely high impedance connection must be in air, not on the circuit board, with the wires all kept short as possible. The Utah group has already sent these slow-scan TV pictures over a 172-kilometre atmospheric optical link in September 2007. Standard fast-scan TV could also be transmitted with only a few circuit changes. So now we look towards one of the world's longest line-of-sight paths, Mount Ellen in southern Utah to Uncompahgre Peak in Colorado, just less than 300 kilometres, across high, dry, largely uninhabited country near the headwaters of the Colorado River. On the summit of Mount Ellen, this pit is a remnant of an earlier world record for optical communication, set with an early technology on the 17th of September 1894. That was when the US Army Corps of Signal Sergeants sent the longest ever optical Morse communication to Uncompahgre Peak via articulated heliograph mirrors. 114 years later, we plan to span this historic test range again, this time with audio and video. But we'll do it inexpensively, without lasers, and avoiding optical coherence. Thank you so much for attending this lecture, and we'll field some questions as soon as the end credits conclude.
And that was a lecture delivered in January 2008 in San Jose by yours truly, with Mike 7MJ and Clint Turner KA7OEI providing the authorship behind it. Now let's leap forward to January 2021, when I took a team, myself, Dave Stuart VK3ASE, Stephen Langley VK3SL, and Stephen's son Henry VK3FACT. We all went from Port Albert to Deal Island by boat. I must admit I was vomiting every 40 minutes on the boat over as well, so I didn't look too good by the time I got to Deal Island. But our intent was to bridge Victoria and Tasmania with a two-way speech-modulated light beam, which we did with the able assistance of a shore party from the Latrobe Valley, Chris Morley VK3CJK, and Ralph Edgar VK3WRE, who manned a station up in the Strzelecki Ranges in Gippsland at a place called Blackwarry. And as you see there, the distance spanned was 136 kilometres. This is how it panned out in video taken by Dave up at the Deal Island Lighthouse site that night. Now there's Erith Island. Erith Island down below. There's Steve and I holding the transceiver unit.
1, 2, 3, 4, 5, 6, 7.
Transmitter lead is in the left lens, receiver is in the right, and they're completely isolated,
See it on the hill over there?
so we can talk in full duplex.
Now. 1, 2, 3, 4, 5, 6, 7, 8.
We were scanning the horizon for the other light.
I'm hearing navigation lights going
And the VHF support was by Baofeng.
Okay, we're about to start scanning the horizon with the light VK3CJK, VK3AML.
Yeah, Roger, Chris. I'm looking through binoculars now, so go ahead.
Okay, it's not quite dark yet, so you probably won't see us until it's properly dark. Like seeing, if we can't see stars, you won't see this. Could you hold that, Henry? Thanks.
Using a rifle sight to line up, but we couldn't get the exact angle until this.
When you're getting to maximum brightness, you're quite good. That's better.
Dave was shooting in
Hello,
infrared.
Can you read me? VK3WRE, VK3 Alpha Mike Lima, Portable 7 on Deal Island. Can you hear us? 1, 2, 3, 4, 5, 6. VK3WRE, VK3 Alpha Mike Lima on Deal Island, calling and standing by.
Could you put the tone on again, please, so we can just speak it on you?
It's on.
That was the Baofeng backup.
Yeah,
Tell them
Roger,
it's on.
tone's on at the moment, no problems at all. VK3WRE, VK3SL and company.
We're straight at him, aren't we? I think.
Yes.
We've just spanned Bass Strait, mate.
Well, we haven't quite spanned the whole strait. We've got it underway. So good, there's a full jet.
And that's the two-way audio.
Okay, do you have two light beam units there? Do you have two light beam units there?
There's Henry.
Mine's probably the brighter one.
Yep.
Being tested and it does work. Would you like to have a go with Ralph? Over.
Okay, let's stand by for Ralph. This is VK3 Alpha Mike Lima by light beam to VK3AML Portable 7 to VK3 WRE now, VK3WRE. Do you copy VK3AML?
You're not hearing that at all, Ralph?
Contact and prove that it can be done.
Indeed so, and yes, well, certainly we extended our original distance record, so it's a good thing, Chris, over.
Yeah, well, we've extended the Victorian distance record. We're not up to the 168k that I did in Tasmania in 2005, I think it was. But that was exceptional circumstances.
Yeah. So, very good.
Bit of wind about.
Incredible. I can have just a normal duplex conversation with you.
Yes, it's good, isn't it? It's, like you say, full credit to Mike. He's done a lot of work in the background, certainly. And,
Mike said it. Mike's had a very bad year of it, so...
Yes, I believe.
And I'm just putting my hand over the mic so that...
Less wind.
Yes, we've got a lot of wind up here. Right, well, I've got 2 sets of headphones here. I don't know who's on the other set at the moment. Who's on the other set? Anybody? Just hang on a sec, I'll put somebody else on. Okay. Steve, are you here?
Yes, I am. Who am I talking to? What's the call?
You're talking to Ralph VK3WRE down there. Have you got the headphones on?
Okay, I'll just put these...
Where are the headphones?
We're using to record.
Where have the headphones gone?
Okay, we're right. VK3WRE, this is VK3SL, and looks like we've got a result.
Yeah, finally, after all that chatter on the repeater. That's excellent work, Steve.
Oh, congratulations, Ralph. It's great. We can see your light on the horizon. It's really quite a... It looks really prominent, actually. It's like a star rising above Earth Island.
Yes, it certainly is. I remember when Chris and I did it back in 2007, it was very much like this as well. Very bright.
Yeah, no, really good copy, actually. It's great. So, well done, fellas. It's a fabulous outcome. I'm sure this can all be put together as a excellent YouTube specimen in time. So, yeah, good effort. Wonderful stuff. Right,
certainly.
Yeah. All right, VK3WRE, VK3SL. I'll pass over to Dave if you want to. Dave's busy with the camera.
Dave's trying to get a recording of us, I think, in infrared light, or the little light that he can manage while we're transmitting.
Yep.
I'm actually recording on a little digicorder, so everything that's happened tonight has been recorded, and I'm getting sufficient backscatter on my own signal to record my end as well.
Yes, I've been getting plenty of backscatter on my system of Chris and vice versa.
Yes.
Plenty of... You played the Groth in front of us, and that causes...
I'll put Henry on.
FACT, okay, yep.
VK3WRE, this is VK3FACT. It's pretty cool to be able to talk through like this.
On the old white thing, yes?
Yeah.
What's your name, okay?
Henry.
Okay.
Yeah.
ACT, yeah, I have to remember that.
Yes.
Very good.
Cool.
It's quite remarkable.
It is. I've never seen something like this before.
As you know, Chris has been working on this for a long time.
Yeah.
I've been at it since about 2006.
Wow.
Yeah. It's quite a remarkable thing.
Well, yeah, great to talk. I'll pass you back on to Chris.
I think the intention is for Dave to intercut our end with your end off the digicorder.
Oh, okay.
So we'll be able to make a YouTube clip of this. We've taken hundreds of photographs since we've come to Deal Island. I wonder how far this is. It would be over 100k, wouldn't it?
How far is it?
Okay, you're asking Ralph how far this is. Any idea?
135.
130.
This is actually a historic moment. Oh, let me pay some tribute. Let me pay a tribute to VK7MJ, who was instrumental in the design and construction of a lot of this equipment. Yeah, well, very, very well done. Congratulations to both of you. I really wasn't expecting this to work so well. And now on to procedures in Britain. You're about to see a lecture by Barry Chambers, G8AGN, given to the Cardiff University Amateur Radio Society in 2019. I have applied to Barry for permission to run this. Haven't got a reply from him as yet. Barry, if you're watching and you want me to suppress this for any reason, I can easily remove it from the upload. But in the meantime, this is Barry Chambers, recorded about 3 years ago, talking about the latest developments in Britain. And Barry has applied some very interesting ray tracing techniques to improve the optical side of the system. Barry Chambers, G8AGN.
Well, good afternoon, everyone. The beauty about this lecture slot is that everybody falls asleep or it's after lunch. So, what you can see on this title slide is actually an LED, which is a fairly modest powered LED, but it's being seen through a lens. And it's
now, if you want to watch the video side of this, and you're listening on 147.475, which this week has a degree of hum on it for some strange reason, I will, after the transmission, do some investigating. There's obviously a circulating Earth problem somewhere. It's not affecting intelligibility, but it is rather annoying. It's not appearing on the stream. So we go back. If you want to look in, please Google VK3AML 8 October 2022, and that phrase VK3AML 8 October 2022 will take you to the live stream and the video and diagrams that go with this audio. Back to Barry Chambers, G8AGN.
10 kilometres away, but you can't miss it, can you? It's a bit bright. But we'll see later on what some of them look like at much longer distances than this. I thought it's perhaps just useful to just remind you of what we're talking about here. Now, the frequencies we're talking about here are so high and the bandwidths are so wide that it's useless to think in terms of frequency. And so at optics, we normally talk in terms of wavelengths. And the wavelengths here for visible light, which is what we're mainly talking about this afternoon, are hundreds of nanometers, basically. So green light, which is where our eyes are most sensitive, is about 550, and red light, which is where most of our systems work, is about 600, 650 nanometers. You might say, well, why do we use red light rather than green? And it's partly because of the properties of the atmosphere, because we have to take into account things like visibility. It's a bit not quite the same as microwaves, really. So what we've got here is a picture which is essentially showing you the transmission coefficients through the atmosphere this way between 0 and 100%. Now this is assuming there's no rain around, that sort of thing, or cloud or mist, but against wavelength of the radiation. And essentially this tells us where we ought to be operating. If we're down here, 400 nanometers and below is where we're into the dangerous UV, the stuff that causes cancer and so on, so we don't really want to be down there. And also, by the time we're down here, our eyes are not very sensitive to that. So there's an obvious eye hazard that if you're starting to operate high power UV sources, you can't see them, so that if the thing's turned on and you look at it, you might do a lot of damage to your eyes, so that's probably not a good idea. Whereas here, if we come up here around about 600, 700, now these curves are for different elevation angles, so we really ought to be looking towards the horizon, so these curves are probably lower than this for towards the horizon propagation. But we can see that if we come up to, say, 750 nanometers, there's a big absorption due to oxygen. And then if we go up further, about 950, which is in fact where TV remote controls work, again there's a water vapor absorption band. So those are not places you'd want to use for line of sight through the atmosphere and communications. So this is another good reason why we're around here. But also there's a window in there where you're up into infrared, which is actually quite a good place to be, if you could see it. But there are ways around that. So this is why we're around here. I still haven't answered the question, why don't we use 550, which is where the eye is most sensitive? Well, normally we operate at night, although you don't have to. But we find actually that because the atmosphere is never really clear, or not very often, you get mist and so on, especially if you operate over cities. And the red light actually goes much better through this crud in the atmosphere than green will. We've done tests with different wavelengths, and that seems to be the case. So we're really going to talk about around about 600 in what phones. Right. Well, we must start with sources. And I've got a couple. Well, I've got one source here, and also a photodiode detector. So I'm actually going to pass those around. That's why I rushed out of the room. So I'd forgotten to bring them in. We tend to think of LEDs, the stuff that panel lights, these sorts of things. Some of those actually can be surprisingly potent, and you might be able to work a few kilometres with those at night. These are rather more powerful ones. These are called stars because of the shape of the PCB that they're mounted on, the heatsink that they're on. And some of those might be 3 watts DC power input, so a few hundred milliwatts optical output. But the things that I tend to use these days are these, and there's one of those coming round now. You better see the size of it. This is a good source of these has been on eBay from TV projection systems. There are 3 of these. There's a red one, a green one, and a blue one. These devices, when you see them, they're not that big, but they're running at 2.5 amps per square millimetre DC current. And so heat sinking is quite important because typically you're running these things at least 8 amps standing current. So that's getting on for 20 watts input. And when you're on speech peaks with modulation, you could be up to 16 to 20 amps peak current. So, heat sinking is really quite important at this stage. But that amount of heat that these generate, because they're only about 15%, 20% at the most efficient, so there's a lot of heat coming off them. But that isn't necessarily a waste. You can put that to use, especially if you operate at night, and I'll explain why later. If I don't, then just nudge my memory. So these are LEDs, the ones at the top. This is a laser pointer similar to the one I've got here. Some of the early work was done with lasers. People like Alan White at G8LSD and that crowd down there used lasers. I know from experience, that they're incredibly difficult to aim because the beam width is very, very small. And also they're potentially dangerous in terms of eye hazard. So they're not to be recommended, especially nowadays when people don't like these shining lights around aircraft and things like that. And I do know 1 or 2 people who've been fingered by Special Branch when they've been near airports shining lights. So we tend to use LEDs, and there are other reasons why we might want to use those as well in terms of setting up systems. Well, I thought it'd be interesting to just come back to the point I was making about frequency and wavelength earlier. And I'm lucky enough to have a couple of computer-driven spectrometers which are based on diffraction gratings and charge-coupled device detectors. And what I did was I measured the frequency spectrum of one of these laser pointers and a fairly medium power LED, and the scale down here is in nanometers, and so this laser pointer looks as though it has if you saw that on the spectrum analyzer at microwave frequencies, you'd say, oh, that's not bad, it's a nice stable sort of source that we've got here. Well, forgetting about phase noise and things, but if you actually look at this, the resolving power of the spectrometers is 1 nanometer. Now 1 nanometer, a change of 1 nanometer at these frequencies is probably a bandwidth of 1,000 gigahertz or something. It's incredibly big. So these are by no means narrowband sources. And if you look at a standard LED, you can see that the width of the curve here is very, very much brighter. So within that, you could probably transmit all the bandwidth that you require in the world at some instant in time. It's probably thousands of gigahertz bandwidth there. It's incredibly wide. So we're not too worried really about narrowband and wideband in that sense. And also we have to think about the way in which we detect light. So in terms of optical detectors, what can you use? Well, there are various things, and some of them have advantages, some have disadvantages, but phototransistors, pin diodes, which are the ones, these are the things we normally use as our detectors. LEDs themselves can act as optical detectors. And so you can actually make a transceiver by just using one LED. You can use it on transmit, you can use it on receive. And you can do clever tricks with them on receive to improve the, in quotes, noise figure of however many hundreds of dBs it might be. Also another possibility is avalanche photodiodes, and these are very expensive though. You're talking about $1,000 a shot, that sort of amount. You can buy much cheaper ones which have been used in cameras, electronic cameras, but the size of the detector element is very, very small, and that has limitations then in terms of the optics of the rest of the design, which I'll come on to in a while. So we'll stick really with pin diodes. Now, photodiodes, of course, are not narrowband detectors. They will more or less detect literally from DC to light. And what I've done here is to show the typical silicon photodiode response curve with wavelength. And I've just shown up here the 4 particular areas which might be of interest to us. So if we were operating just on the edge of the UV band, about 400, you could buy LEDs here on eBay. I think they're really sold for helping cannabis plants to grow, but they don't actually say that. but they do, you can get quite a lot of output power at 400 nanometers. But they are dangerous, so not something you really want to use. A lot of LEDs are around about just over 600. That one that's going around now is about 625, something like that. I mentioned earlier about a window in the infrared band, so you can buy infrared LEDs at quite high powers. And an infrared system actually works better than a red light system in terms of penetrating the atmospheric muck, as it were. And then up here, which is where the peak of the response curve is where the TV remotes are. But if you try that outside, you'll find that the atmosphere isn't very transparent there, as we showed earlier. So that's the place actually to be avoided, even though it looks quite nice in terms of the detector sensitivity. If you want to work down at UV, although silicon photodiodes work reasonably well, you can fall back on the old photomultiplier tubes, which people used to use years and years ago. And I'll show you an example of it, a piece of gear that does use one of those later. Now, let's talk about antennas. Well, we use lenses in our case. But the same rules apply, that the bigger the aperture of the antenna, the more gain it has and the narrower the beam width. And that's fairly true for optics as well. Now, if you think about lenses, then you tend to think about, lumps of glass with nice smooth curves on them. But in fact, you can make these a lot lighter by using a so-called Fresnel lens. And the most common example of those is if you ever go into a lighthouse and you go up into the place where the light actually is, and you look at the chunks of glass that are there surrounding the light, that is actually a Fresnel lens. It's essentially a stepped lens. So every time the thickness of the lens increases by a wavelength or a few whole numbers of wavelengths, you can chop that piece away and step it back, and that will still act as a good lens. And the lenses that we tend to use are things like this, and again I'll pass this around. It's an A4 size page magnifier. And at one time, one of the remainder shops were selling these at 99p a throw. And you see, the aim is not necessarily to use a lens to give you a high quality image, which you would have in a camera. All you're interested in is gathering the light. You're not worried about forming a beautiful, sharp image at the focal point of the lens. The lens is just there to collect enough light and dump it on the surface of a photodiode. And because the the size of a photodiode is several millimeters square typically. As long as you can get all the light dumped down in that area, you don't care about the quality of the images, as long as the light gets there. And so you can get away with things like this, which are less than perfect lenses. Because obviously the steps that you get here, you get effects which degrade. If you use it as a camera camera lens, it can degrade the image, because you get diffraction and scattering and all sorts of things. But here we don't give a damn about that. We just want the light. If we just look very crudely at receiver optics, basically we have a lens as big as possible to pull in as much light as possible, and we want to bring it down roughly to a focal point where the photodiode is. But we find that we can never actually, with this type of lens, we can never actually produce a very sharp spot image at that point because of the imperfections in the lens. And you end up with what's called a blur spot diameter, which is typically D over 1,000, something like that for Fresnel lenses. So, you know, we're talking about a blur spot diameter of 2 or 3 millimeters at best, and sometimes it might be a lot worse than that, depending on your lens quality. So that's all we need, basically. Transmit side is a bit more difficult, because if we're using LEDs, so if we've got an LED here, and we've got a Fresnel lens here, now F over D is like you have in camera lenses, the ratio of the focal length to the diameter of the lens. F over D equals 1 seems to be about optimum for the sort of systems that we're playing with here. But you see here that if this is the radiation pattern of the LED, then you can see that a lot of the light spills over from that and never goes through the Fresnel lens, so it never gets transmitted into a tight beam. It's wasted, basically. So we need to think about how we can improve that radiation pattern, if you want to think of it in those terms. Well, if you look into this, you find that if you buy sort of what I might term proper LEDs, high power LEDs, then assuming you're not buying them from eBay, if you're buying them from a reputable manufacturer, often they will be able to supply what's known as a ray file. And what they've done is they've taken an LED in a special rig, and they move it around in all possible directions in front of a detector, and they record for every possible set of angles the light which reaches the detector. So essentially it's like a 3D radiation pattern. And what they do then is they do some processing on that data, and they translate that into a set of rays of light which are coming out in well-defined directions in all possible angles, and the intensity of the light in those directions. And you end up then with a so-called ray file. And these may have anything between 100,000 and millions of hypothetical rays of light coming off the surface of the LED. And what you can do is you can then write an optical tracing program, and you can follow how each of these individual rays of light pass through an optical system. And in our case at the moment, we've just got an LED at the focus of that lens that's coming round, and then we want to see how much of the light actually passes through that lens and how much is wasted, so not used. So I wrote some software to try and do things like this. And here's an example of a Golden Dragon's particular make of reasonable power LEDs, and I'm looking at 5 million rays of light in all possible directions coming off the surface of the LED, and I'm then seeing how many of them actually will pass through the area of the lens. So each of those dots you can see on there represents something like 50 rays of light. And what I did was count up the number of rays of light that were actually emitted. I know it's 5 million. How many actually passed inside the area of the lens? And it was about 13%. So that obviously means an awful lot of the light is wasted, which is bad news, isn't it? So what can we do about that? Well, what you can do is that you can have your LED, which is just there, and you can put in front of that a secondary lens, which is of this peculiar shape. So it's a sort of bullseye type lens. It's got very sharp curvature on both the outer and the inner surfaces. And the idea of that is that effectively it bends the rays of light which will be coming out up here somewhere. It bends them in so that they will actually pass through the area of the lens.
And this is VK3 Alpha Mike Lima. I might mention there that I think I was the first person to apply that optical system back in 1988. If you care to look on my YouTube channel, you'll find a video of myself and the old VK3AML testing the first of my Fresnel lens rigs, where I was using a secondary lens because I tried it and it worked. It did produce more output. I didn't have an explanation for it until Barry Chambers came up with that ray tracing program. This is VK3AML. If you want to see the video that goes with this audio on 147.475, please Google VK3AML 8 October 2022. Back to Barry Chambers, G8 AGN, with his lecture on amateur optical communication.
The only penalty you pay with that is that when you do the ray tracing, you end up with a virtual image of this LED, which means that the actual beam of light that comes out here is wider than it should be. But that doesn't matter. In fact, that's beneficial in some ways. So if we do that experiment again, we've got the same LED, the same 5 million rays of light we're tracing through the optical system. So we've now got this peculiar shaped lens just in front of the LED, and then we can see now that this is the light output, and we can see that a lot more of it actually gets through that lens. So we've improved, if you like, the ERP basically of the system. So you can spend hours playing with it, things like this. But I also did this practically in the sense I set up a little lab, as it were, in the lounge, turning all the lights out and everything. And I set one of these up, and then I photographed it with the camera, and then I processed the image and drew contours of light contours across the surface of the image, and I looked to see what it was like. I did a whole series of tests like that, and it confirmed the optical ray tracing I've done. Right, so let's turn really more to sort of how we put this stuff together. This is a very simple system. All systems are wideband. It's all really DC. There's no sort of RF stuff here. So if we've got an LED, obviously we might want to put some bias on that, bias current, and then we could have an audio amplifier, and then we're just feeding that into here. This is amplitude modulation, basically, or if you want to send CW, you could have a 555 to give you a square wave, and you can just key that. Or you could send data in, and we've done that as well. On the receive side, you've got basically a crystal set and an audio amplifier on the end. So it's extremely simple to do. Right, so putting a system together, the person who has guided me most is a guy called Clint Turner in the States, KA70EI. I should say that at the end of the talk, I've got some sheets which give you lists of interesting websites and things, sources of information. So if you want one of those, Derek has some of that. My transmitters use these flat lights, about 5 watts out, I reckon. They're very, very bright. They look just like a searchlight beam, red searchlight beam, which comes out. If you want to see what one actually looks like in practice, I've got some videos which I might show later on in the afternoon if anybody's interested to see them in action. But you certainly wouldn't want to look at one of these. You definitely get eye damage if you did it. But because you can see this beam of light coming out, it makes aiming of this in a particular direction very easy, because you just move it around until the beam's pointing in the right direction. As I said, the receiver, basically a photodiode, audio amplifier. In my system, I tend to use separate transmit and receive, so I've got 2 of these A4 page magnifiers, so that the system is quite big. But that's good. Solid construction, tripod. and also a telescopic sight with crosshairs is quite useful, especially if you're looking for somebody from the other end, because sometimes the things aren't quite as bright as that first picture you saw. Right, so I'm just going to show you a few pictures of the gear. So that's the receiver back end, that's the transmitter back end, basically that's the modulator. And I'll show you the circuits and so on involved with these in a minute. Telescopic sight on the top, that's just a Morse key on the top. And because where I live is high up and windy, then we need big trunk. That's the front of the system. You can't see a lot from that, apart from the fact that you can see there are two of these Fresnel lenses. If you look inside that big box, on the left-hand side we've got the transmitter. So behind this, well, sorry, on this heat sink, which is a computer heat sink with a fan on the back, there's one of these LEDs that's going round, and then this is the secondary optics. So the Fresnel lens is sort of further down to the bottom of the picture. And then on the right-hand side, this is the receiver preamplifier. I'll show you the circuit in a minute. And then on the front of this, there's an infrared filter plus a red piece of filter material, again photographic. And a useful source of this stuff is that reputable photo shops, camera shops, will sell you a little book of samples of filter material, and they have maybe 100 to 200 samples in. And each, so they're all different colours of the rainbow, and each one normally has a sheet of paper with it, stapled on it as well, showing you the response curve of the filters. So it's easy to see which colours you actually might want for the particular system that you're using. And these books of filter papers are very cheap, like you just pay for the postage basically, maybe £1 or so. But there's enough material on these to make quite a few filters. Rather than buying, a huge, great sheets of filter material. I was talking about heat sinking. This is another system. This is an earlier one. This is only a 3-watt device mounted on a heat sink, and then I've just got the secondary optics there, which is just held in a pipe clip. So it's a bit crude, but it works. I said that these devices produce quite a lot of heat as well as light, and if you're operating on a hilltop somewhere in the winter, you tend to find that the lenses and so on get covered in dew. But here, of course, you've got a lot of heat coming out of this, and you've got a fan on the system, and so it blows warm air around the enclosure, and so it keeps the lenses clear of dew. So it's sort of recycling energy, as it were. Right, this is a typical amplitude modulator. There's nothing very special about these. So just a speech amplifier, quite a big beefy FET shoved in there. There's the LED, and this is basically just a feedback loop to set the current, the standing current for the LED. Because this bit runs on 12 volts, this bit runs on just over 5 volts typically, because there's nothing in the circuit which actually drops much voltage. That's just a sensing resistor for the feedback loop. And so I normally have one of these down converter, voltage down converter thingies, these switch mode power supply modules. So that produces about 16 to 20 amps at 5 volts. And they're so efficient that they don't lose much power in terms of heat. But otherwise, if you're running everything off 12 volts, you've got to have a whacking great big resistor in there, which will drop 7 volts at 5 amps, or 20 amps, and that's an awful lot of heat loss. So it's better to start with the low voltage at that point. You can feed in data as well, and we've fed in things like SSTV at this point in the system, and it works very well. So this is amplitude modulation, it stands there. That's what it looks like inside the modulator. Notice the high frequency construction technique there. That's the current sensing resistor. It's only one ohm, but it's got a lot of current going through it. So nothing very special. This is a receiver front end. So the important part is here's the photodiode. It's actually reverse biased, and that's to reduce the diode capacitance, so that increases the bandwidth a bit. The frequency response of these systems drops off very rapidly, even at sort of high audio frequencies, and so we try and put some reverse bias on this. And also there's a differentiator circuit here which gives you 6 dB per octave boost at the high frequency end. There's just a constant current source there. And the most important thing is that the gate of the FET there has to be in air. The connection has to be in air. You can't just point it on a printed circuit board. It's got to literally be stuck up in the air. And that's to make sure there's no leakage at that point, electrical leakage. That's what the back end of the receiver looks like. It's got 3 bits in. At one stage I had an audible S meter, in other words, as the signal strength increased, then the pitch of the tone increased, but I found it a bit useless, and so I gave up on that. Much more important is that if you operate over cities, and unfortunately we have to do that in this country often, then you get interference from street lights, and it's typically like harmonics of 50 hertz, so you get 300 hertz is a very typical sort of hum you hear in the background. So that's a 3-phase supply, and of course with lighting you get twice the cycle in the AC.
LED street lights.
Sorry?
LED street lights. Have you noticed?
Well, we've just been converted to LED street lights, and I must admit I haven't listened to any yet. And I'm dreading what I'm going to hear. But this, for the more conventional lights, is very, very effective in taking out a load of crud. It really is. But again, it was Clint who developed that, and I had some collaboration with him on that. If you want to test your receiver, then it would be nice to have some test gear. Now, of course, there isn't test gear, at least not the sort of stuff that we can buy. And so what I wanted to do was to build up a system which is rather similar to what you would use for measuring the noise figure of a microwave receiver. So you want a noise source that you can switch on and off, and you measure effectively the signal to noise, when the thing's on, when it's off, and you can work out what the noise figure is. Now to do that, obviously you need a calibrating noise source. We don't have calibrating noise sources, but all I'm doing is using an Arduino to switch an LED, a small LED on and off. And that is mounted at one end of a long piece of drain pipe. Now this is very short here, just for the purposes of illustration, but typically that's 2 or 3 meters long. And so there's the noise source LED at one end, and my receiver front end is at the other end. And you have to do things like make sure that the ends are light proof, there and there, and you also have to line the inside of that tube with black flock paper, which doesn't have any reflections, so you don't get wall reflections, because that upsets your results quite a lot. There were 2 ways I was doing this. One, I was literally getting the Arduino to measure the receiver output when the noise source was on and when it was off, and I can adjust the brightness of this, in other words the current going through this, to adjust the brightness of the LED. So as your receiver gets better you can crank down effectively the noise level. And then I had a second version of this where I just had this on all the time, and then I looked at the signal from the receiver and Fourier transformed it to look. I wanted to look at the frequency spectrum of the signal coming out from the receiver, and then I could look at the noise level well away from the received signal, because I was modulating the noise source at, in this case, about 970 hertz. And so on the frequency display from the receiver, I get a spike at 970 hertz, and a bit away from that I just have the background noise. So if I take the FFT and I take appropriate contributions to where the 970 is, and then I look at some of the contributions well away from that, which is the background noise, then I can get signal to noise from that.
This is VK3AML with a regular Saturday night test transmission. In this case, we're broadcasting a lecture by Dr. Barry Chambers, G8AGN, on optical communication for amateurs, modulated light communication. I apologise for the quality of the audio on this. It's recorded obviously on a video camera some distance away from Dr. Chambers, but the content is just so pertinent to anybody who wants to build this stuff that I feel obliged to include it. I only wish that Barry had been wearing a microphone at the time. We'll push on. I'll be going for a live callback at 11:15. This is VK3 Alpha Mike Lima. If you want to look in on the video that goes with this audio, please Google VK3AML 8 October 2022. That's Google the phrase VK3AML 8 October 2022 and you'll get the video and diagrams that go with this audio. VK3 Alpha Mike Lima. Back to Barry Chambers, G8AGN.
And that seemed to work well. Because this thing is not calibrated, I can only get comparative measurements. So that would tell me whether, what I've done to the receiver is getting better or worse. But it's quite useful to be able to do that. If you want to test out in the field, this was a system I set up at one stage. I've got an optical sensor in there, and then I've got a piece of board with these reflectors, the sort of things you put on the back of trailers and things like this. And then I had a long piece of cable which went from the optical sensor back to where I was, which might be 100 meters or more away, and I had a little box on top of the receiver which measured that voltage from the optical sensor. So I could then adjust the focusing of my LED with respect to the Fresnel lens and so on. So it was a sort of distant signal sensor, basically. Path planning. Well, you can use the same tools as you use at microwave frequencies. The only difference is that our K factor for optics is not 1.333, it's about 1.17. And that's because if you look at the formula for the refractive index there, it's different at microwave frequencies and optical frequencies. The water vapour isn't very important at optical frequencies. In terms of refraction, it's obviously important in terms of visibility through the atmosphere, but in terms of ray bending on these coverage charts, it's not important. So it's only the gases that are important. Making an optical contact, well, pointing is quite important because some of these systems are very narrow beam, especially if you use lasers. It's virtually impossible. Rifle scope is good, or a good pair of binoculars. If the target at the far end is visible, then if you're using one of these LEDs with a wide beam, you just go zonk and you're there. So you don't even need this. And there have been times when we've used this sort of thing for lining up like 47 gigs systems. You do get atmospheric scintillation, which you would expect, because if you go out at night and look across the city or something, you've got hot air rising, you can see the street lights appear to twinkle. That's atmospheric scintillation. And you can hear it. Can you just knock the lights down for a second?
Yes.
Lighting control.
Yes.
What's it say? Minimum lighting or something? All right. The only reason I wanted the lights down is because you may not be able to see this otherwise. But this is shooting across Sheffield at night, and this is an 87-kilometre path. Now, notice the QRM. I don't know whether you can actually see it, but the light is just there. You probably can't see it. It was only just visible. And you really needed binoculars to spot it. You couldn't see it with the naked eye almost. I mean, this is obviously a camera shot, so it's integrated the light a bit. But that just shows you what you may be up against.
That one to the left, Barry, usually got the right one.
Sorry? No, there is a light right over there. That isn't it. This is another problem because the more wind farms that get put up, the more red lights that you see around the place. And the last time that I used my gear was on November the 5th. and we were actually trying to do a 47G test over about 80k. And we actually had to use red light to set it up to work out which direction you're going. But there were so many red lights all over the place from wind farms and fireworks going up. And you can actually hear the fireworks on this, surprisingly enough. So it's great fun. Can you just mark on, please? Thank you. Optical records. Now, it's surprising how far you can actually work, but I'll draw your attention to this. In 1894, the US Army used flashing mirrors, heliographs, somewhere in the desert, I guess in Arizona or something like that. And they achieved a contact or passed the message 293 kilometers. No one has done that yet with amateur optical systems. When lasers were first invented, the helium neon lasers, there's a couple of people in the States who used one to work 189k, 1963. The actual world record really for a two-way contact is Clint Turner's group, 278k. Now he lives in the States, he can drive up 5,000 foot mountains, the atmosphere is totally clear because it's dry. Now you think of the atmosphere in this country. So if you look at what's been done here, it is quite modest. We know there are paths longer than that which will go, but it's finding the day when it's sufficiently clear that it will work. That's the big problem. Now having done stuff at night, and we thought it was rather easy eventually to do that because we worked out how to do it, we then thought we'd start trying to do some in daytime. And we set ourselves some very stringent rules, and that was that it had to be done within at midday plus or minus 1 hour, when the source of QRM was at its most intense, i.e. the sun. But we did cheat a bit because we only looked at east-west paths across the country, and of course we knew the sun would be due south at that time, and so that helped a bit with reducing the QRM. But we've only managed 83k so far, and the thing was that I could see on that particular day, it was quite a clear day, I could see where the person at the other end was through binoculars. I could not see the red light. And that's even with, one of these high power lights. But I could actually see, there was like a sort of a bit of high ground with a hedge running along the top of it, and it had a gap in it where he was. I could see where that gap was at this distance of binoculars, but I could not see his light. And it took something like over 2 hours to actually make a contact. It was just because the light level was so high from the sun that the noise level was way, way up. But it's quite a challenge to do it in daylight, but it's good fun. I thought I'd just add a few. How are we doing? Give me another 5 minutes. There's just one or two other things, sort of supplementary things I wanted to mention. One is filters, because I mentioned earlier that the receiver is quite useful to have a filter across that. Filters are not narrowband things at these frequencies. This is an interference filter, and it only works for normal incidents, because if you have a piece of glass which is of a particular thickness, then it only works when the light goes perpendicularly through it. If you have light from your Fresnel lens coming in at an angle, then the frequency, or if you like, where the curve is, it shifts. So it's very difficult to actually make a very narrowband filter. And so the filters tend to be wider like this. That's a microscope filter, actually, that one. But this is a piece of the photographic film I mentioned earlier. And you can see that's actually just known as a high-pass filter. I think that's not really indicative. I mentioned photomultiplied tubes, 931. This does work at UV. The only reason I put this in was because the power supply for the photomultiplier unit was from a bug zapper. One of these things that looks like a tennis racket you can buy in the summertime for zapping bugs. And the supply in that is 1,000 volts or more, quite high impedance, but it's enough to drive a 931 tube. I'll forget about that, but you can also modulate using pulse width modulation. Variation on that is sequential multi-tone hell. I'm interested in that because of doing non-line of sight paths like cloud scatter, possibly using infrared. In fact, this is an infrared system. It's supposedly a high-power LED array in there with a sort of bullseye lens on the front. Again, you can buy these off eBay for helping plants to grow. But that's just showing the hell received over a short range. And this is a sheet of information, websites and so on, which Derek has kindly done for me. Well, thank you for listening. That's just an arty shot my wife took once, and I was out testing, so that was my LED, and there was the moon up there, and she liked that. And what else I would say is that I have got the componentry of a simple optical link using multi-tone hell driver if you want to see it working. And there's some videos I can play if anybody wants to see me showing things in action. Maybe SSTV. It gives you an idea of what things sound like and what they look like. Thank you.
Dr. Barry Chambers, a talk he gave at the University of Cardiff Amateur Radio Club in 2019, and in spite of the rather poor audio quality, I thought that was very worthwhile putting in, because so far as I know that's the most complete summary of present amateur radio optical communications that I've come across in any lecture form. And if Barry is watching, thank you very much in advance of anticipating your allowing us to run that. While I'm at this, I should show you the latest development in LEDs, which Barry mentioned. It's called the flat light LED. There it is on a big CPU heatsink to which you normally fit a fan. Hang on, I'll see if I can get this to go in. There we go. The chip, the central chip underneath the glass cover that you can see at the centre of this is about 1.5, maybe 2 millimetres square. Now, to give you some idea of how efficient these things are, I can connect my ohm meter running on its lowest range to this LED, and that's the output of that LED almost blinding the camera with 1 milliamp going through it. I should tell you that these normally run at 8 amps. Now you can imagine the intensity and the brightness of this thing. I'll just key it on and off, obviously instantaneous, very high conversion efficiency. These things are used in projection TV systems as very pure sources of primary colours, red, blue, green, or cyan, magenta, yellow, whatever. And they're intended to replace xenon arcs in video projectors, which they probably eventually will do. But from our point of view, the red one, this particular one, is probably the best present LED source for optical communication through the atmosphere. And there you see it running on 1 milliamp. 1 milliamp. If you multiply that by 1,000, you get 1 amp. Multiply that by 8 and you get its maximum current. It is a fearsome modulated light source. This is VK3AML. I'll shortly, when I clear the desk of all this stuff, go on to 2 meters to take a callback. I'll keep it short tonight, as Rowley in Auckland is already up at, what would it be, 1:17 a.m. in Auckland. Sorry, Rowley. And behind me, this is, I'll bring the microphone a bit closer, this is the duplex optical communication unit that we took to Deal Island. It's on a very shaky tripod at the moment, but as you can see, it's made in a truncated pyramid shape. The idea of that is to keep the photodiode and the LED absolutely rigidly held at the focal point of the 2 lenses. That lens is the transmitting lens, this lens is the receiving lens, and if I apply the battery to this, a 12 volt battery, I'll just connect it. There we go. It's very highly directive, so I have to point it at the camera to give you the effect of this. As you can see, it's incredibly intense and it's very well collimated. So that's the actual device that we took to Deal Island that made it over, what was it, 136 kilometres, and it has the potential to do much more. Okay, I'll raise the level controls on monitoring off air. I'll switch my monitoring to off the mixer so I can hear people calling me. Sorry, this is all very extemporised and rather amateurish. Get myself my notebook. It's a bit harder to do when you have all this gear cluttering the shack, but I wanted to show you those various pieces of optical communication gear. Okay, VK3 Alpha Mike Lima now calling CQ on 147.475 and standing by for any calls. And I see somebody calling me, but I don't hear anything off the mixer. Hang on. I'll call again and put it on speaker. I can't understand why we have no patching at the moment. I might have kicked it out somehow. Let's just have a look. That goes through to there. Ah, yes. I see the problem. Okay, would you care to try again? VK3AML, standing by.
Yeah, VK3ECG. And VK3ACZ.
Sorry for the delay, gentlemen. VK3ECG, Dave, and VK3ACZ, Peter. And welcome back, Dave, after quite a gap. Hope you're keeping well. You might like to tell us how it all went in the UK and how you're doing. VK3ECG, and sorry for the delays today, but it's a fairly complex presentation. VK3ECG and the group VK3AML.
Yeah, VK3AML and the group VK3ECG, yes, and good evening, Peter. Yes, well, I was here last week, Chris, but yes, I've had a bit of an interesting time both away, and then when I came back, getting caught up with quite a few sort of concerts. Actually, we had 2 weekends of concerts, and that rather dominated my time and so on. And now, of course, we're working our way towards our Christmas concerts, which, of course, are not so far away. It sounds terrible to say that sort of thing at the time of the year, but That's the way, Christmas often starts a little bit earlier for those musically inclined, if you see what I mean. So I have that myself, and then my wife's doing her Renaissance dancing Christmas concert, which I have some minor role in, one that does not involve me, however, doing anything with my feet in the way of dancing, because I have two left ones. Yes, fascinating talks this evening. I very much enjoyed that, and remembering watching the Deal Island video in the past, and seeing Steve in full flight, and of course Henry as well. It's absolutely fascinating. I'm always intrigued because with the sort of the issues and systems between coherent light sources and the problems with lasers and the atmospheric effects and so on. And one of the things that's always occurred to me was really a bit about the one was sort of a slightly amusing thought, I suppose, and one which was what about noise from acoustic sources that shake the air? So, for example, thinking of things like potentially low-frequency interference that could come from, say, air vibrations from a wind farm, or if you were to transmit across the, say, a large arena where there was a rock concert going with those very, very heavy speaker systems with a lot of air movement, whether that in effect would actually form form part of a sort of QRM caused by a pattern of air shifting and moisture and so on. And the other thing that also occurred to me is thinking about some of the radio astronomy systems where, again, using widely spaced antennas, would a multiple path system, either with multiple transmitters or even a multiple receiver system, but where you're actually looking through a different airway path, would that actually have some discrete benefits, and do you know if that's been used at all? Anyway, that was just sort of some thoughts while I was watching. Certainly, some of the laser hazard one was fascinating at the beginning, and having this sort of whole heap of really quite interesting sort of medical laser stuff. But people forget, of course, that not only is acute UV damage and corneal damage, and a lot of that was, in fact, all experienced by the arc welders and so on. It's quite significant. You can get quite a lot of corneal injuries associated with that, to say nothing of the laser stuff as well. Although, of course, it's an effective treatment in certain conditions as well. Anyway, back to you, Chris. VK3AML on the group VK3ECG.
No other breakers. VK3ECG and group VK3 Alpha Mike Lima. You bring up a number of interesting different problems there. As far as acoustic interference with the beam, the only acoustic interference I've ever struck is shouting in the days when I had very much less firmly mounted photodiodes and LEDs, shouting into the back of the optical receiver unit. You could sometimes get a resonance of the optical focal length, just a little bit of background noise, but not very much. As for it in the air, the only circumstance where I would see that happening is if you're using coherent light, a coherent beam, a laser beam, and the frequency of the sound was sufficiently high that the pressure waves would be coming close to the wavelength of light. There was a device used for mechanical television, for projection television systems, immediately before the Second World War, a brilliant device called the Jeffrey cell. it was just a glass long tube, square-shaped tube, containing a suitable liquid. You would put a quartz crystal at one end and modulate it, let's say, with a 5 or 10 megahertz RF waveform, which would set up very, very narrow pressure waves, particularly standing waves in the water or kerosene tank it was, more often than not. And by modulating the amplitude of those pressure waves into the quartz crystal, you could actually modulate a light beam going at right angles through the crystal through the diffraction grating produced by the pressure waves, so that the beam would split into two parts. And in that way, with a suitable obstruction beyond the Jeffrey cell, you could modulate the intensity of the beam using ultrasound effectively. It's a very early usage of ultrasound. And the Scophony company, Scophony, the Scophony company, commercialised mechanical scanners using those particular sort of ultrasound modulators between 1936 and the Second World War. After the war, CRTs became much more the done thing, and they had other means of screen projection that didn't rely on mechanical scanners. But they did get that system going for 405 line British TV pre-war. Multipath systems, it's an interesting one, using multiple transmitters and multiple receivers, looking through a different column of air, as it were. Yes, we've tried it. In 2005, when Mike VK7MJ had his light box, I suppose you'd call it, on top of Mount Wellington in Hobart, and I was at the top of Mount Barrow outside Launceston with the late Joe Gelston, 7JG, and Jason Riley and half a dozen other spectators. I had two optical receivers spaced about 2 or 3 metres apart, each feeding a different loudspeaker. And interestingly, standing between the two so that you got this stereo effect, you could hear kind of when one would transmit maximum level, the other would be minimum, and vice versa. So by combining the two, the depth of fades that you were getting as a result of scintillation would be reduced. It's simple spatial diversity. It's used also, I believe, at microwave frequencies. And you can even do it at HF by using a vertically mounted antenna dipole and a horizontally mounted antenna, also a dipole, on, say, 20 metres, on the 20 metre band. And sometimes your signal will maximise coming in on vertical polarisation and sometimes on horizontal, depending on the chance state of the ionosphere. And then it's just a case of having two front ends and picking the one with the best signal. And there are some software-defined receivers with multiple front ends that are designed to do that very thing. The AGCs of the two receivers are combined so that effectively only the receiver with the best signal will get through at that particular moment. I hope I've described that. Arc-I, yes, the hazards of welding, fairly well known, and arc welders, being a bit macho, tend to take off the goggles from time to time to show off, and they end up with horrendous eye damage from the ultraviolet. Apparently it feels like somebody's thrown sand in your eyes. It's like sunburn of the eyeball, except it can be much more serious and much deeper. Okay, round to Peter VK3ACZ. Hope you're going well, Peter. I missed the Sherbrooke Radio Club. I completely forgot about it. It's my fault, my bad. So I'll come next month with my head hanging in shame. VK3ACZ and group, VK3AML.
VK3AML in the group, VK3ASE. Good evening, Chris. Good evening, Dave, and to any other listeners. Yes, your presence was missing and noticed, but no, all good, just so long as nothing too dramatic happened. I think there are about 15 there on Monday night. It was your usual meeting. Paul, AHM, gave a little lecture on the components that he salvaged out of radios. We saw the usual number of radio-related videos and so on, and I think we're all gone by about 23:30, so it was an early finish. Anyway, on to tonight's business just for a little while. Yes, it was good reflecting back on the time that you were on Deal Island, because I remember fondly the 80-metre net that we had there with Trevor down in Bairnsdale, hosting as Master of Ceremonies, and I've heard that recording a number of times of all of us. Who could forget Peter Parker, VK3, Yankee Echo, going down to, what was it, 8 milliwatts or something, and you were still hearing him? I think I lost him at about 20 milliwatts. He's about 25 kilometres away from me, but a little bit of suburban QRM meant that I couldn't pick him out like you probably would have, Chris. It was a wonderful time, and it's good to be able to share it in the memory. Light transmission, I'm sorry to say I'm a little bit ruined by Star Trek, and before you start wondering if I've lost my sanity, I kept thinking of those photon torpedoes that they constantly used to blow up the enemy spacecraft there, so absolutely wrecked me for thinking about light transmission. Okay, enough of the silliness aside. A wonderful couple of days there with DX, Chris, especially on 20 metres. I had quite a few contacts with England yesterday and today. Where was I? A place called, I don't know if I can pronounce it for you, Dave, Atoxeta or something, in Staffordshire, England. 9+ signals both ways. I got out my little 818 Yaesu and had another chat with an Italian station there, gave me a 5x4 with 5 watts. Always love to do that on the long path in the afternoons. But anyway, better not keep it too long. You want to get moving. Thanks as always for tonight's broadcast. Some very interesting stuff there to absorb at my leisure. And back to you, VK3AML in the group, VK3ACZ.
No worries, Pete. Thanks for that. And my signal on 2 metres is a little down. I see it's the SWR on my antenna is slightly higher than it was. I think it slipped a bit further down the pole, so I need to hire a handyman to pull it down so I can stick a new lead on it and get the active part of the antenna above, being parallel from its support mast. It actually is slowly slipping down the support mast, particularly after we have windy days. As for where the hum's coming from on 2 metres, I'm not sure. I'm going to have to do a lot of tests with circulating earth loop problems. There are so many connections now with Zoom and 2 metres and the 3 cameras and the 2 computers that there probably is an earth loop somewhere that I haven't detected. Anyway, back to you, Dave, and good luck with the Christmas concerts. If you ever want to have them broadcast, you should record them and then submit the tapes to Dave 3ASE, who's running his shortwave station up at Newborough, north of Bendigo. I'm sure he'll always appreciate a bit of program material. Dave, I saw the last few weeks on one of the nets is getting a lot of flack from conservative amateurs on one particular band. I mean, for goodness sake, give the guy his due. He's actually objected to what happened to Radio Australia, and he's gone some way to replacing it, at least in terms of a domestic shortwave service. The power that he has available may not be enough for international, but he's covering quite adequately, from what I hear from Web SDRs, everywhere from the western border of South Australia all the way east as far as Rotorua. He's getting out like a ton of bricks, and that's with only 200 watts. So round to VK3CG, Dave. VK3 Alpha Mike Lima.
Yeah, VK3AML, the group, VK3 ECG. Yes, fine. Yeah, interesting. I'm not sure. I think I just missed the name, Peter. You were saying about the place you worked, Staffordshire, which is the potteries, the famous potteries where Wedgwood and all of those places, well, are still. But the potteries was a famous place, and that's where you had those wonderful trades like the saddle maker's bottom knocker, which is always a rather nice one, as a trade within the potteries. And yes, Chris, I had heard the hum, and it seems to be just sort of a low grade there on all transmission, not just this. So as you say, it's not really part of the what happens on the stream, but it's just looks like it's just the RF 2 meter side. So yes, these things are terribly difficult to run to. I was going to say run to earth to find out what's going on, but that may be a slight pun, of course. Yes, in terms of the recordings, one of the groups I sing with actually has got quite an elaborate setup, and they actually, I think with COVID, they arranged the president is actually a sort of electronics computing person, and he has arranged to have the concerts actually put up as paid feeds. And then that's for the whole concert, and then I think they make some individual videos out of it and then put it up separately on YouTube as and on their website as general promotional material. But the actual concerts themselves you could buy tickets for, or you could buy an online pass for a number of days, and quite an elaborate setup. That was about, I suspect, about sort of 5 meters worth of table of varying gear for audio and sound, so he did quite well. But I think he's done this a couple of times now. Yeah, so, but the other large group I sing with hasn't really done any of that sort of thing, although they have made recordings and have had some nice recordings made in the past, and but they've not been broadcast or anything like that. Although I certainly could raise that with the committee. I'm sure they'd be delighted. There being, of course, no issues around copyright, at least from the point of view of the original author. Seems most, or the original composer, seems most of the works are well over 100 years, if not more. And although I think for the current Christmas one, there's going to be some more modern works which actually do fall within the copyright period. But there we are. It's really interesting. Some people who have not done that, for example, one of the great choral writers still alive today, Rutter, with the Ukraine situation, wrote essentially really a hymn or an anthem in very much Ukrainian style, as a sort of anthem for peace. And he wrote this, I think, really just over a sort of an evening or weekend, and he immediately had it sort of laid out as a formal publication, and then made it freely available, and it's now being performed by choirs all over the world, actually, in concerts, as a completely a copyright-free work that they can do what they will with. It's fascinating to see how those sort of things do come together. He must be in his 80s now, I think, but a remarkable composer. So yes, some interesting things. Yes, I had a quick look on the Jeffreys cell. Fascinating, isn't it? And really creative sort of thinking about how to modulate things using that interference effect. Fascinating. Yeah, I just thought the multiple sources. I mean, I was sure somebody had done that. I was just interested to see how far apart you need to put the transmit pathways through the air in order that those sort of pockets of air that cause the fading and so on are going to be separate. I mean, obviously there must be sizes of these pockets of air of different optical densities and so on that must form, and presumably it's different in different settings, different humidities and wind patterns and things like this. I wonder whether there's some sort of optimum separation that's going to give you the best rejection. I mean, it's like the systems for antennas in cars as well, isn't it? The diversity sort of systems that do the same sort of thing. But I just wonder what the distance would be that would make it optimum. So there's some interesting experiments you could do in that sort of area. Anyway, back to you, VK3AML, the group VK3ECG.
VK3CG and group VK3AML. Well, one of the most interesting experiments that we have done is to take an ordinary white painted piece of board, plywood, 6 feet by 6 feet, something like that, and then take one of our optical units with a well collimated beam, lots of red light power, several hundred metres away, and just fire it straight at the board, and you can actually see the pockets of air focusing, defocusing, and it gets worse the further apart you are. As for the optimum spacing, I suppose that would depend on wind speed, how fast the pockets are moving through, but in general that's one of the reasons we use Fresnel lenses, because they have a large aperture. They aperture average over a large area, and they're much, much lighter and cheaper than the equivalent glass lens in terms of aperture. I'll hand it round to Peter VK3ASE for a final on this band before we switch to Zoom. I see it's getting to 1:45, so it'll be midnight before our Zoom finishes. VK3ACZ and the group VK3AML.
Yeah, VK3AML and the group VK3ACZ, and thanks to Dave I'll be able to, I've been watching the live chat on the side of the screen there, so all good. Dave, the place was, it's near Croxton, no, I better not pronounce it. It was in Staffordshire, and I had a very nice contact there. A couple of Welsh contacts as well. Twice this week I've got into the banks of the Red Sea, Jeddah and Saudi Arabia there. 7 Zulu 1 Victor Delta in his motor vehicle with a quarter wave whip on the top of his car. That was quite enjoyable, and as I said, it's been a fairly good week for DX, and no wonder with the solar figures going up. Anyway, Radio Australia, Chris, you surprised me. If there are objectors to that, surely not. Surely it's something that's applauded by everybody, but then again, somebody spoke to me this week about a person who's not very happy with these Saturday night broadcasts, and I was astounded to find out who it was, but they certainly don't need to be listened to, that's for sure. Your signal strength, no variation on what it usually is, given that VHF, as you know, can be a little bit atmospherics dependent, whatever it is in the air there. I notice the repeaters around Melbourne vary a lot on the signal strength, but you're rock solid what you usually are week after week, and that's with my 991 alpha signal strength meter, so it's fairly reliable, at least in terms of its highs or lows. The other thing is that I wouldn't worry too much about that hum. You're aware it's there, but only after after you've brought it to my attention. So all good there. Back to you and move on. VK3AML and the group VK3ACZ.
VK3 Alpha Mike Lima. I'm just typing at the moment the meeting ID number and the passcode for people to dial into Zoom. 815-6195 and 7235. That's the meeting ID. And now the passcode for Zoom. Small n 86 X B for Bravo 9. And let's see how long it is before people actually dial in to speak to us on Zoom. This is VK3 Alpha Mike Lima, and just standing by for anybody to come in on Zoom. I'll just check what I'm actually radiating here. Looks like we might not have any takers this week, which would be a bit unfortunate. VK3AML, standing by for anybody who wants to chat on Zoom. And if we see nothing within a couple of minutes, I'll cut it out. I'm actually radiating via a webcam. Ah, who's this? Tom George. Hello, Tom, and how's Ballarat? VK3 Alpha. And there's Dave. Oh, somebody's got a speaker up. Hang on a sec, I'll just bring up my own screen. There we go. And I'll get rid of the figures over the top of Tom. There we go.
There we go. Yeah, I just sort silencing my end as well.
Yeah, hi.
Yes.
Oh, we've got a feedy back. Yeah, Tom, I hear the Ballarat Amateur Radio Club is looking favourably upon our suggestion of doing digital slow scan over their repeater.
Yeah, no problem.
What's the situation there?
I left actually send an email to our secretary tonight. Haven't heard back. But the guys have been playing around with EasyPal on our local, one of our other UHF repeater we have that the club owns, and they've been getting some fairly good results with it, which is great.
Oh, good.
But I actually, when you started to come on air, I said, I must find out for Chris if anything had come back. But Mel hasn't sent me an email back yet, but you'll be the first to know, eh?
Okay, thanks. We did have we did an attempt to do a EasyPal on the Mount Macedon repeater in response to some people north of the ranges showing an interest in that. But Amateur Radio Vic pointed out it's the only repeater that gets you well north of that range, so it would be blocking other people out on a repeater that's heavily used. G'day, Rolly. Sorry to keep you up so late.
No problem at all. No, there's no problem at all. So there we go.
Well, the news, as I think I mentioned last week, is that Gary 3GLC, who joined our Zoom chat only 2 weeks ago, passed away literally on the day following our Zoom chat. So that was really a shock. I've heard since then that he actually had a couple of kids too, so I didn't know him that well. I'd met him on a couple of occasions with Peter 3ACZ particularly. We met at One Tree Hill when we did a BHF field day up there.
And he came to the club meeting a couple of times too, Chris.
Yeah, on his Triumph motorcycle. He was very healthy. He was not yet 60, which is a worry from my point of view. Gosh, heavens. Anyway, and Dennis, how are things? I presume you're in Canberra still?
I'm in Canberra. It's very wet down here with since the January 19 bushfires, which seems like ancient history. It's just been raining almost constantly here. It's been almost like Melbourne all through August and September multiplied by the year. So a number of years ago, many years ago, I was in Melbourne, and I was there for 3 weeks for work, and it rained for 21 days, 20 days of the 21.
Yeah.
So there you go. It's a bit frightening with your friend dying just before 60. I hit 60 tomorrow.
Oh, congratulations.
Yes, so it's quite
in 2 years I'll be hitting 70, so it doesn't worry me anymore.
As my GP says, you've reached the dangerous age.
Oh,
that's what he kept saying to me. I thought most uncomfortable thing to say to your patient.
Oh, well.
Yeah, well, the thing is a lot of people have gone in this last couple of years.
Yes.
COVID and other things. I had a business partner, and he wasn't that old. He was 73, and he's got cancer, and he's on his last legs, so it's very sad.
Hang on, I'm just trying to get a light here, that's a bit better.
Yes.
Yeah, it's difficult to get the lighting right. Point a webcam camera at the Zoom screen and and control the sound at the same time.
I'm using my iPad actually, because my main setup is downstairs in my sort of work study. This is upstairs in the shack, and it's much better set up actually in my work study, because I've been using so much online Zoom for everything, including teaching stuff and actually giving evidence in court on Zoom and things like that, which has been quite interesting. And yesterday I finished up doing a interview for Channel 7 for TV, and they were most impressed that I had a Rode microphone on a boom and all the rest of it.
Yeah. When I tried to get my first decent webcam was when COVID first started, and surprise, surprise, they were completely unavailable from one end of Australia to the other. Everybody had bought them.
Yeah, for a while I actually used I got one of those HDMI interfaces for my Fuji camera I had, which was had a nice video thing on it, and I used that, and that was tremendous because, of course, you could frame everything, but in fact, it was just a pain to use. It would run out. You had to run multiple power supplies and things to it, and it was very tedious to use. And eventually, I stopped doing it because it was, to be honest, the sort of 4K sort of video cam thing for computing was probably just as good for what I needed.
Yeah.
But it was certainly gave a very nice image, and what's more, you could just control it a bit more in terms of what you were doing. Whereas on this iPad, of course, it's got one of those sort of face following things where some of the computer cameras do as well, but and that's quite handy, I suppose.
Yeah, the thing I noticed having to buy cameras over the COVID period was how much they've improved of recent years.
Yeah.
Automatic focus, 90 degrees coverage of the lens, and because they can make the sensors far higher in definition, you can electronically zoom without losing quality. Some of them even have optical zoom. It's just extraordinary what's happening with imaging technology at the moment.
Yeah, and the light sensitivity is amazing as well. So it's more about getting even lighting rather than sufficient lighting, which used to be the problem.
Yeah, the thing that I noticed with the old webcams is that they would go to half frame rate once the lighting was below a certain level, and that seems to have stopped. I'm looking in the back of Rolly's room, and there are various certificates on the wall, Rolly. What are they about? Yes. Are they awards for competing with a key or something?
That one there is DXCC for CW, and that's 322 countries. That one here is DXCC single sideband, and that's 340 countries.
Oh.
That one there is a DXCC digital, and that's 290 countries.
Yep.
And that one's a DXCC mixed bands, and that's 344 countries. And that one there's a DXCC honor roll.
Holy moly!
If you get, I think you got to be within 10 of a full sweep of all the XCC countries. So I think it's 340 something now. So the minimum would be 300 something odd, 333 countries.
I would ask, what's the rarest? North Korea, at a guess?
Oh yeah, I've only got two countries to get there to full sweep. One of them is North Korea, and the other one is Scarborough Reef.
Scarborough Reef.
Is there anybody in North Korea?
Oh, there are a lot of people.
There's a lot of people.
They can't say much.
In North Korea, but yeah. There has been a couple of de-expeditions. Well, I know of one de-expedition that went to North Korea. Really, it was more of a this is what amateur radio is about, and can we show you what amateur radio is about? And I think they made a total of about 200 contacts, and then they were politely asked to leave their equipment behind and exit the country. Goodbye.
Ooh, okay.
And that was it.
Yeah. I did notice that
there's been lots of attempts, including myself, to try and get back there again and do something there, but it's too dodgy, really, at the moment.
It's particularly at the moment. I went to a lecture by one of our Chief Justices, one of the former Chief Justices, who was on the United Nations panel for investigations into human abuses in North Korea, and the stories he had were frightening.
And it's like it's like many countries in the Pacific. Even when I go out to Papua New Guinea, for instance, the sequence of events is let's have a good old biffo first, and then we'll talk about the problem. You know.
It reminds me of certain radio club meetings, but anyway.
I remember looking at visiting South Korea and going to the demilitarized zone and looking out over that huge expanse with there's a quite a nice sort of I suppose information centre with a bell that will be struck on the day that Korea unifies and so on. But what amazed me was the number of various sort of semi-military security incursions that seem to be occurring right through until the current decade. So you think of these sort of standoff, but they've been these raised tunnels being dug, and some of them are only just a few years earlier.
Who does them? Who mows the lawn between the two?
Somebody that they want to sentence to death, I suspect, with all of the mines that must be there.
It's and they had actually I think they had a little enclave, a South Korean enclave in North Korea, where they actually had a sort of factory and various things that you could travel through it. And every time some little hiccup occurred, they would block off the enclave for a few months until things they got what they wanted or whatever, and then they let it all happen again. But it was mostly for making sort of craft goods and things like that, and sort of touristic things.
Yeah. And how much of what you are allowed to see is reflective of the truth is another question.
Absolutely.
Perhaps we shouldn't talk about this on ham radio, though. And I look forward to the day.
Well, it's not really political in that sense. It's just the facts of what's happened and what's been reported.
Yeah, I just look forward to the day when the thing that I notice about all totalitarian regimes is that they have a certain limited shelf life, and no human can put up with it for that long, even if it's whole country. And the French had an interesting way of dealing with their problems back in the 1780s. And Cromwell, of course, in the case of England.
Yeah, absolutely. That's sort of, again, it was a sort of religious puritanical and as well as political, I suppose, in that era. But essentially, it was fascinating how the community responded in the Cromwellian era, particularly around religious ceremonies. Christmas, for example, was a good example of the way in which the community almost rebelled against the Puritans, and there was only so much they could do to damp down the sort of celebratory elements.
Yes.
Interesting.
Well, Tom, what's going on in Ballarat? There must be something that you can talk about with the Ballarat Amateur Radio Group.
Oh, it's been wet and people have been doing all sorts of weird and wonderful things. Not a great deal. It's not the sort of weather that our microwave guys usually get out and about for. Other than that, not a great deal. We've sort of been out for social meetings and our usual Thursday morning coffee mornings, but as in the way of anything technical and amateur radio happening, I don't think so. Probably next month we will, because the VHF-UHF contest will be coming up again.
Okay.
So a couple of guys will probably get involved in that and try and con some more people into joining them. But we're looking at the club rooms at the moment. They've just drilled a trench through the backyard, putting drainage and so forth through the where we are, as you imagine, is the old radio school out at the airport.
Yeah.
And we've got one of those buildings, and we rent them from the council. Now, the council is under a
from memory,
obligation to maintain
it's a long,
those.
low building that dates from the Second World War. Would that be right?
Yeah, that's correct, yeah. Yeah. And they've got quite a few of them out there. There's car clubs and darts clubs and aero club and everything else occupy them. But the council has to keep the infrastructure up because of the, I think, the historic value of it. But we're about to have our access road cut off and a new one put in because they're redefining the arterial loop around Ballarat. And they've done some major road construction to help move traffic around. Because they've declared an area near the club, near the airport, which used to be what they call the bomber landing strip. That's now an industrial estate.
Okay.
So they've got to sort of make access for traffic. So we're in the middle at the moment of working out whether we can get the council to help us with some, not so much renovations, but repairs, because the roof happens to be that funny blue stuff made.
Oh, asbestos.
And
best left where it lies.
And it's best left where it lies. So if you want something done in a ceiling or spouting done, it becomes a bit of a major problem.
Yeah. Are there still planes landing at that airport?
Yes, certainly are. Helicopters and all. Elvis lives there during the firefighting season, or one of his brothers. Yeah, an awful lot. They used to have air shows there 30 years ago. So, yeah, it's still majorly used. There's a couple of aircraft engineering companies there, and also a flying school. And I think it's a commercial flying school because we see a lot of Asian guys come down to the supermarkets. They get out of a bus and they've got all their commercial flight uniforms on and everything else. And they've come from one of the schools that works up there. So it's still fairly active. One of the other things is I think they're aiming to add some length to one of the runways.
Okay.
Which they want to try and do, and actually getting rid of one of the access is probably going to let that do that. So it's on the up and up as long as there's money there to do it.
When I was at the Film and Sound Archive years ago, I remember having a look at a film. I think we included it in that videotape we made called Living Ballarat 1901-1941. It's coverage of an air show at the Ballarat Airport in 1930. And they're all, I think, Gloucester Gladiators or something, doing target practice with mail bags or something. They could fly them very close to the ground and drop the bag within 6 feet of the target. You can imagine if they'd got some ground turbulence, that would have ended fairly quickly.
They then stopped having them. They were quite big. There were probably thousands of people there for over 2 days.
Yeah.
And they had everything from ultralights to helicopters. Of course, the Air Force had their little display and everything else.
Any Hamfests planned, by the way?
No, not at the... We've got our one on the 5th of February for our Hamvention.
Right.
We're starting to get things together now. There's some advertising going out for that. And that won't be all that far away from the club rooms. It's there's a building adjacent to us owned by the Polo Club.
Right.
And the guys went over there and had a talk with them, and they've given us a weekend access at an excellent price compared to where we previously were, which had actually doubled its price for the use. So we sort of work out that we on the social side of things, we still make just as much money from a Bunnings sausage sizzle. but still, the social side of things and everything else, you still have to have your Hamvention as regular as you can. And now that we've got these COVID restrictions being lifted, it's good to see that most of the clubs around Victoria are actually kicking in and getting things running again.
I do notice that when I go to Hamfests, I see interesting pieces of old equipment like roller inductors, and the same roller inductor will migrate from one table to another as one person buys it, finds he has no use for it, sells it at the next Hamfest, it goes on to the next person, and the next Hamfest you see it again. So it gradually migrates around the population of the Hamfest. Rolly, do you have Hamfests like that in New Zealand? Do they have get-togethers with buy and sell?
Yeah, we do. There's perhaps the guys down the South Island are fairly active in that sort of stuff in Christchurch, and then there's one major one in the North Island, I guess, and that's in Hamilton. That's on a annual basis.
Okay.
And yeah, you're right. The same roller inductors, they end up over here, and the large capacitors, and occasionally somebody will buy them up, and you'll hear them on 160 for a while, and then they're gone, and everything's...
Yeah. I just
I've got a question.
Sorry, go ahead.
I've got a question for Rolly. When did you go on to daylight saving? Because we went last weekend. Did you do the same?
Yeah, last weekend. Yes.
Okay. Yep.
Yeah.
So we've not got you at 4 o'clock in the morning or something, Rolly?
No, you've got me at 2:07 at the moment.
I feel continuously guilty about that.
No need to do that. This is fairly regular.
I don't think Rolly got all those certificates on the wall from working office hours.
No, that's very true.
No, no, that's for sure.
I've got a deceased now, great uncle, Jim Watson, VK3NQ, his call sign was. He was active before the war and just after the war, and I've actually been able to find him in all sorts of places. He used to write some regular paragraphs for the AR magazine when it was a Ronioed copy sent out before the war, and I've got some scanned copies of those you can get online. But I found out the other day he's got a Worked All Continents award, and this would be before the war.
Oh.
And the only rig I know he had was a Hartley oscillator on 40 metres.
You can bet that would have chirped a lot.
CW. He operated purely CW. So I've even got a picture of the radio, a whole stack of prints that he's taken, and also everybody else sort of around the world sort of sent him. A lot from ZL, an awful lot of stuff from ZL. Some Polish and a few from Europe. One guy there, he's in his shack, and his shack happens to be the bench at the chemical laboratory he works at. And there on the back shelf are all the glass bottles of all the chemicals, and that's where he operates his shack from. So it might be a bit volatile there, but it didn't seem to worry him.
Yeah. The thing that I noticed about early New Zealand amateurs, and I've read a little bit about the activity, particularly in the South Island, there were a lot of YL amateurs very early on. Even in places like Dunedin and Invercargill, there was some pioneer YL operators over there in the 20s and 30s. It's surprising.
The YL operators are still alive and well in New Zealand. In the early, back in 1980s and so on, I did a lot of the expedition stuff around the Pacific, and my wife decided, right, there's, of course, no cell phones, no nothing in those days, so in order to keep in contact, you're right, I'll get a ham radio license as well. So my wife is also she's still quite keen, and it's the YL scene here in New Zealand is quite alive and active still.
I sometimes wonder where those women were when I needed them in my 20s for a date to increase my shack.
The annoying thing is my wife's call sign is 01 Foxtrot Victor, so a 2x2 call, and I had to put up with a 2x3 call.
Oh, right, okay.
Wasn't what you knew, it was who you knew at the time. So.
Oh, I see.
Can I grab the screen for a tick, Chris?
Yeah, sure.
Can I grab the screen for a tick? Just hang on a tick. Well, okay. You've actually disabled screen sharing because I can't share. It says the host has disabled participant screen sharing.
Have I? Hang on.
Yeah.
How do I
by default
share screen? Do I hit share screen?
Yeah, you can share screen. You may have to go to your settings to allow people to be a co-host.
Share sound, optimize video. What do I do? I'm not that familiar with all of this. Forgive me. Stop video. Choose virtual background. Where the hell do you find that? I'm sorry about that.
Yeah, no, that's no problem. Don't worry about it too much, Chris.
Hang on. Advanced sharing options.
Yeah, it'll be in that.
Host only, all participants.
All participants.
All participants. Multiple participants. Okay, that's all done, I think.
Yep.
Okay. There you go.
There you go.
Okay.
Yep, sharing.
That's 1932.
Oh,
lovely.
Wow.
From ZL.
Easter camp at Waimate. Okay.
I've got quite a few of those, and some from guys that are sitting out on the side of a hill in the rain, covered up with tarpaulins.
Jesus.
Operating radio. And
if that's a dipole, they could have done with a squid pole. It's about 6 feet off the ground. Dear, oh dear. Now, what's happened to my camera? Good, now I've done it. There we go.
Haven't turned yourself off, have you?
Yeah, I think I did.
There we go.
Mostly my wife does that. I don't have to worry about it.
By the way, how is she, Chris?
Gradually recovering. Spinal surgery of any kind is the sort of thing that you need really 12 months to recover from properly.
Yeah.
She's walking with a frame, but not because she absolutely has to have the frame. It's because it extends her walking distance, and it allows her to get around shopping malls. But her... how can I put this? She doesn't want to acknowledge that she's getting elderly, neither do I for that matter. And the existence of the frame, looking at it across the room, is kind of depressing. So we tend to hide it in the spare room until we absolutely need it, or leave it in the boot of the car where it doesn't remind us continuously that we're getting older. But Prue, she's doing pretty well. The only thing is she looks after the 2 grandchildren of my old friend, the old 3AML, who died sadly at the age of 61. And we had, by the time of his death, become a part of his extended family, really. And now, of course, she's, because she's tied to the frame, she can't look after the kids as much as she used to, which is really her biggest regret. It's interesting, it's not the direct effects of the operation, it's the side effects, and that's one, just personal things. I'm sorry, I might be boring people.
No.
But anyway,
it's like,
what can I think of to talk? By the way, Rolly, the only person I'm aware of in your country who's done any work with modulated light is Murray Healy, ZL3MH, I think. Murray
I
Healy.
don't know. I haven't heard of anybody operating with it, but
he did a few tests.
Other than with the laden light and sending a bit of Morse code, I've done a bit of that.
Yeah, okay. Aldous lamps or whatever they call them.
Oh yeah, whatever they were.
I applied.
Or shutter in the front.
Yeah.
Good fun.
A little bit slow in modulation for me. I want to do video. In fact, that's the next step. I would really like to, well, Tom, hook up digital slow scan system to the light beam system and transfer digital files, and then to find out if we can speed it up by it's got 20 kilohertz of response without modification. So there's no need to limit it to 3 kilohertz. It could actually transfer video of a limited type. So I want to try that. That's where we're heading anyway. It's the opposite digital direction to what Rex 7MO was doing, which is basically millihertz wide, transmitting only a call sign and R5S9.
It comes down to what bandwidth you've got available on your receiver, because the light's got unlimited bandwidth.
Well, exactly.
As you say, it's hundreds of megahertz bandwidth.
That's the overwhelming advantage of it, plus privacy. The other thing, which we pointed out, Mike VK7MJ and I visited the Dunedin branch of NZART in McAndrew Street, Dunedin, and they were having a lecture, and at the end of the night somebody said, can anybody suggest a suitable project that would get young people in on amateur radio? And Mike and I looked at each other and said, why don't you try modulated light? Even if you make a little optical unit, you can have kids talking back and forth on that, and if the regulations in New Zealand are anything like they are here, you don't need any licence for it. If they licensed that, they'd have to licence every TV remote control in the country. So they seem to look upon that with some enthusiasm. It's a fairly enthusiastic group in Dunedin. I was really surprised. For a town its size, they've got their own permanent meeting room, and quite an active group. Seems to come every month. Meeting ending in 10 minutes. I'm not going to upgrade. I'm a cheapskate. There we go. Anything anybody else would like to ask of anybody else in the group?
I would mind asking Rolly a question. How active is the Wellington group in Z Art?
Well, there are a couple of groups out there. There's a regular club, then there's a sub-sort of club called the Wellington VHF group. Now, the Wellington VHF group, they're quite... I believe they're quite active, but I haven't... that's way down the other end of the country, so I don't really get a lot of contact with them down there. But, from time to time, they come up with the odd bits and pieces. I normally get in contact with these guys when they shoot out on and do summits on the air or parks on the air and that sort of stuff, and because I'm quite active in that sort of program, and so that's normally where I get hold of them. But the Wellington VHF group is quite an active group, I believe.
Okay. Yeah, no, one thing I noticed with New Zealand, I lived there for 3 years, about 10 years ago. New Zealanders were very, picking up on Chris's point, they were very, very active in club activity on a whole range of things, and lots of different things. New Zealanders, I don't know what it's like in Auckland, but certainly around Wellington, it was, people just had there were lots of hobby clubs, all sorts of things. There's one guy, a guy called Peter Fry, who was a radio announcer for Radio New Zealand, and he used to run a Saturday night program. He had a 78 record club, so the 78 record club from all these old Bakelite, whatever the 78s were made of, and they'd meet quite regularly. There's just lots and lots of different clubs in Wellington. It's a sort of place where it's pretty easy to find something interesting to do.
Yep, I agree. Not so much in Auckland, but certainly Wellington would be the area for that, for sure, here. And Christchurch is not far behind either.
Yeah. Lots of mountain goats doing a lot of climbing and solar activations and peaks and so on.
Auckland's quite spread out. It's a distance problem, whereas Wellington, everything's crammed in together on the hills.
Yep.
There's one thing that I noticed when I was over in New Zealand the first time. We were going through a town called Matamata, and there are a number of antique shops there, and I went into one, and I was aware, having worked in archives, that the first commercial disc recordings made in New Zealand, recorded by the pre-electric process with a portable outfit, was taken to one of the western suburbs of Rotorua in 1927 during the visit of the Duke and Duchess of York. And the engineer's name was Reg Southey. I later met him. He was the engineer for Columbia Records in Homebush in Sydney. And blow me down, I'm in Matamata, and there for $1 in a pile of 78s is the first disc of the first series of discs made in New Zealand. Anyway, picked it up, bought it, and later was in Rotorua, and I knew from talking to Reg Southey that these were recorded in a longhouse at a suburb of Rotorua called Ohinamutu. So a friend of mine and I went looking for Ohinamutu. It turns out to be the opposite end of Rotorua from where the famous Maori village is, Wakarawera or whatever it's called. I can't pronounce that, and I certainly wouldn't pronounce it in Australia the way it's supposed to be pronounced, Rolly. But anyway, we were sort of sitting in front of the the longhouse at Ohinamutu, and I took a bit of video, and this big Maori chap comes out, and I thought, oh, here's trouble, because, you know, they can do the eyeball bulge and all the rest of it if somebody else looks like they shouldn't be snooping around anyway. He said, do you have some interest here? And I said, well, I've got this recording in the car that I know was recorded here in 1927, one of the first, probably the first commercial disc record cut in New Zealand. Pulled it out, showed it to him, and the name of the singer was a 19-year-old girl named Anna Harto. And he said, Auntie Anna, she lived up there, and literally pointed at the house. It's a weird spot, though, because the longhouse is like 10 yards away from this lawn, and then there's a little picket fence in a circle in the middle of the lawn, and there's boiling water bubbling up. It's unnerving. Anyway, in the course of this, while I was talking to this chap, and Mike 7MJ was with me, this lady comes out with a stick and a calico bag on the end of it. This is about dinner time. And the guy says to me, oh, it's just one of the ladies that she's cooking the dinner. And I said to the lady, have you got any sort of formula for this? She said, vegetables 5 minutes, meat 10 minutes. So apparently people have been doing that for time immemorial. They don't have to worry about cooking or gas or heating supplies. It's all there.
And still doing it. And still doing it, Chris.
But after White Island, I think I'd worry about the whole place going up in the air.
No, well.
I mean, you New Zealanders are so blasé about landslips and earthquakes and all the rest of it. It leaves me absolutely amazed. I mean, what happened to Christchurch was bad enough. But the spirit of rebuilding that I struck down there just filled me with admiration for the people, the pop-up city that they had for a while. Anyway, sorry, just observation on New Zealand things that we tend to notice coming from here, apart from the differences in language, calling shopping trolleys trundles and flip-flaps instead of thongs.
When I go to Japan, they often say, what's the difference between the New Zealand accent and the Australian accent? And I say, it's very easy. A New Zealander can become an Australian very, very quickly. Just pinch your nose like that and say, good day, mate, a lot.
I used to cause terrible problems.
You get every Japanese just rolling on the floor when I do that.
Yeah. Well, the only place...
I used to get terrible trouble when I first came here because I couldn't tell the difference between New Zealand and Australian accent.
Really?
And people, it was really difficult. Now it's blindingly obvious to me. They stand out a mile off. But when I first came to Australia, and even the accents around Australia, I couldn't pick them. But now I can sometimes spot someone from South Australia or whatever. It was quite embarrassing, actually.
Yeah,
there's a very different accent between the North Islander and the South Islander as well.
Yeah.
And the further south you go, the more you got to roll your R's. So you come from Gore or Invercargill, you know.
Yeah.
So,
yeah.
ZL4RMH comes to mind. He was originally at Gore. I think he's moved into Saddle Hill near Dunedin now. But he was the chap who had the first Flex radio system I ever saw. 1 minute 44. Could we have final comments from people?
Speaking of radios, Chris, do you know 3IO Ron up there at Emerald?
I've spoken to him a couple of times. Don't know him well. Why?
Okay, now I heard him today working the DX along with me. He's running an Annan. He mentioned that it was a 30-metre high, 80-metre long wire, 30 metres high, but into an Annan, and he sounded really good. Anyway, I just thought of you when he said that.
Emerald, he obviously has gum trees to go that high.
Yeah.
And one day a big wind will come and the damn thing will come down. I know what those things are like.
So where's your Annan?
Well, yeah, I've been holding it off, and the number of people who have them and are satisfied with them is great, but they have a long lead time on orders, something in the order of 3 to 6 months. So I'm a little dicey about it. I'll see, but I do want to go fully digital, having seen how good the systems were. And the first system I saw was Ron ZL4 RMH, or is it ZL3? RMF. That's right. Yeah. He has a terrific.
No worries,
setup.
Chris. Well, it's nearly meant to go. Great content tonight too.
Yeah, I won't be on the Monday net, Tom. I've got an appointment for Monday, but I will be on the Monday after.
Okay, no problems. And of course, our usual Tuesday night club net's up as well. So.
Right. Well, it's going to die. And it's died. Hang on, we'll go back to the normal camera. Sorry about the delay, folks. Okay, we're back on the Brio, and I'll switch off the zoom lamp and go back to the this is very unprofessional of me, and back on that. Your free meeting has ended. Okay, I'm not going to pay for it. Anybody who calls me mean and cheap is no fool. Anyway, fellas, I'm not going to come call back on 2 meters. I think it's about time we finish 12:28, and I don't want to kill Rowley with late nights or become anathema to his family if I'm visiting over there eventually. I do want to be presentable, not like some Australians. Anyway, with that, thank you to all the listeners and to the participants on Zoom and to those on the stream. And Ardran VK3ARD, I think, was saying, Rolly, that you have some seriously impressive awards on the wall. Certainly something I noticed in the background of the Zoom chat. So with that, let me in, Chris, says Rolly. We did let you in, Rolly. One day I'll find a way of running something similar to Zoom chat for a longer period, and we'll be able to switch to that almost immediately after the pre-recorded stuff. I'm looking at the response chart of who was watching what, and when we were showing the material from Deal Island, there was a peak. There was a peak of viewership at 29 concurrent viewers. Good night to John Young. Keza, thanks for the compliment, Keza. Rolly, Ardran, Tom George, thank you for all that you've done in terms of smoothing the way to getting 3RBA going with digital slow scan. It's going to be interesting to see what comes of that. I can certainly get into it very well from here. Who else to thank? Ken Cook, who experimented with music and sound transmission by light beam in the 60s. Using LDRs. LDRs are actually reasonably sensitive as light receivers, as VK3EWG once showed me back in about 1976. It's just getting the light to focus on the distance between the combs inside an LDR is quite difficult, and silicon photodiodes are much quieter. Okay. Don't think there's anybody else to thank except VK Pirate. Nice to see you. And Terry, of course. And at this point, I'll pull the pin. Wish everybody a very good night, and hope to see you next Saturday night. And if G8... Oh dear. Barry, if you're watching, I hope it was okay to use your lecture. We'll certainly remove it if you don't want it to be up there, but it's such a valuable contribution to the amateur side of modulated light communication. It's something I really thought compelled to put up there. You covered the subject, Barry, extremely well. So, this is VK3AML on behalf of the Saturday night session group, wishing everybody a very good week and hope to see you next week. Cheers.